renewable, I would say that participants who actually have questions to any of the presenting teams, you actually may direct your questions in the chat box, and the presenters may actually respond to your questions in the chat box so that we can have an interactive, a virtual session in the chat box, like you ask questions and then the presenters would answer the questions, and we have interactive session between and exchanges of ideas in the chat box. All right. So I think that was a very brilliant idea. Like we have 3 groups presented already, and I think we are ready for the next team. So I shall call for group SG20A020 from Swinburne University of Technology Sarawak campus to pitch your project. Yes, you may request control. And whenever you're ready, you can start whenever you're ready. So yeah, and please be noted that the Q&A sessions is only for 5 minutes, and you can have up to 2 questions. So team, please manage your answers concisely and accordingly to fit that 5 minutes. So yes. The thing about SEA-GIC platform is that it connects these young scientists with the industry people, academicians, for the exchanges of ideas, for us to see what are the potential application in the industry. And we have judges from the industry, like I mentioned just now. We have Dr. Stephen from Universiti Tunku Abdul Rahman Uttar, and then we have Madam Nurida from Petronas Research Sdn Berhad, and then we also have Mr. Chua from Mafa Gloves Sdn Berhad. So this industry people, they would give feedbacks to your project in terms of scaling it up or in terms of practicality of your projects in the industry itself. It's such a refreshing. We can see the exchanges of ideas between academics and also industry. So I shall call group SG20A020. If you are ready, you can start your presentation. Yes.
A very good morning to the honorable judges, fellow contestants, and audience. We are Team A020 from Swinburne Universiti Teknologi Sarawak, Malaysia. My name is Eng Shiyen, and my teammate is Ong Jaling. Today, we would like to present our topic entitled The Future Paradigm of Hydrogen Production via Catalytic Dry Methane Reforming. This is the overview of the presentation. I will cover the first 3 sections, while Jaling will discuss the last 3 sections, starting from project outcome up to the future prospect. So nowadays, global warming has been a hot issue. It raised more and more people's attention, especially some scientists, to obtain sustainable and renewable energy. On the other hand, global demand for hydrogen in pure forms has grown steadily over the past 50 years to around, and it is predicted to be the major energy source in the future. Hydrogen can generate electricity and produce chemicals like ammonia, methanol, and renewable diesel. Due to the emerging technology of hydrogen cars, hydrogen has substantially replaced the use of petroleum in vehicles. And therefore, a dry methane reforming process is proposed. Dry methane reforming can convert methane gas and carbon dioxide, which are considered as greenhouse gas, to produce carbon monoxide and, most importantly, green hydrogen. You may have a question on what feedstock can produce green hydrogen. I would like to say is biogas. Biogas is produced from palm oil meal effluent. The palm oil meal effluent is processed through an anaerobic digestion, which eventually produces biogas with methane and carbon dioxide. By using biogas as feedstock in the hydrogen production, it aligns with the waste to wealth concept, and therefore the hydrogen produced is called green hydrogen. Our topic mainly covers carbon dioxide utilization with a dry methane reforming process to produce hydrogen, which is considered as one of the renewable energy, and also green chemistry by utilizing a catalyst in the process. These are the problem statement and objectives of our topic. We aim to address the drawbacks of conventional nickel catalysts, such as serious sintering and deactivation, the intention of novel catalysts, last but not least, the economic and environmental performance of the novel catalyst-based dry methane reforming. This research project involves data collection to collect all relevant data. This data will serve as the input to the later formulated simulation model in Aspen Plus. An economic analysis will be performed to evaluate the material cost and energy cost of the process. Lastly, an environmental analysis of catalytic DRM will be performed to identify the carbon footprint of a catalytic dry methane reforming produced. The research group has carried out a comparison case study between nickel-based catalysts. To prove the feasibility of the novel catalyst in dry methane reforming process, the research group has benchmarked the performance of nickel-based MOF catalyst, single-atom catalyst, and the conventional catalyst, which is nickel supported on alumina. The MOF-based catalyst is nickel supported on MIL53, whereas the single-atom catalyst is nickel supported on HAP. Now I will pass the floor to my teammate Jialing.
Thank you, Chien. For economic analysis, the information of the amount of raw materials required to synthesize the catalyst is collected and used to calculate the material cost for 10 kg of catalyst respectively. Next, the operating cost of the catalyst synthesis process is also taken into account, such as the cost for energy and water consumption. However, the operating cost is relatively small as compared to the material synthesis cost. It can be clearly observed that the total synthesis cost for nickel MIL53, a MOF-based catalyst, is significantly higher than the others, while the conventional catalyst being the lowest. It is also interesting to note that the catalyst lifetime, while evaluating the feasibility of the catalyst. According to literature, the conventional catalyst has a lifetime of 5 years. It is fascinating to find out that MOF-based catalysts can sustain 3 times longer, and on the other hand, single-atom catalysts can sustain 4 times longer than the conventional nickel alumina respectively. Therefore, in account of a 20 years project lifespan, the conventional catalyst will need to be replaced 4 times. This contributes to the surge of synthesis costs as compared to the single-atom catalyst that can sustain 20 years. Nevertheless, the cost associated with MOF-based catalyst is approximately triple of the conventional catalyst due to its very high material cost in synthesizing them. Moving on to environmental analysis, it can be analyzed on the carbon emissions from the synthesis of the catalyst. From here, carbon emission from the single atom catalyst nickel HAP is actually the highest as compared to the conventional and MOF-based catalyst. However, in account of a 20 years project lifespan, the carbon footprint observed from nickel alumina catalyst is about double of the noble catalyst. This further validates the potential of the proposed novel catalyst in carbon dioxide mitigation. By considering both economic and environmental performance, nickel HFC catalyst is found to be the most feasible nickel-based catalyst due to its competitive cost and environmental benefits. In addition, nickel MIL53 catalyst also possess an undeniable potential in use as compared to the conventional catalyst. This project has provided a useful insight of possible upscaling of novel catalyst production. Furthermore, novel catalyst has proven its capability to replace the conventional catalyst due to its economic feasibility. Novel catalysts are also proven to be more environmental friendly than the conventional catalyst. So, you may have doubt on the upscaling capability. To that, there are plenty of research articles have showcased the possibility of upscaling the proposed novel catalyst. Nevertheless, these are limited to kilogram cells at the moment. Therefore, a 3D printed catalyst can provide an unbelievable golden opportunity for larger scale production. This is because a 3D printer can sensitively control the desired morphology and characterization of the catalyst, which is essential in producing both MOF-based and single atom catalysts. In addition, it consumes lower energy consumption, more cost-effective, and safer operation. In actual fact, there is an increasing trend which proves the capability of producing 3D printed catalysts in recent years. Indeed, this provides a shining future of mass production for both MOF-based and single atom catalysts and their application in dry methane reforming. This brings to an end to our pitching presentation. We sincerely appreciate your attention, and should you have doubts or collaboration opportunities, please feel free to contact us. Thank you.
All right. So Team SG20A020, can you emphasizely relate your project to our theme of this SEA-GIC 2020, which is battling climate change through chemistry? Can you emphasizely relate your project to our theme?
Sure. Because we utilize the carbon dioxide that actually released to the environment that can impact the environment to use as a feedstock to produce hydrogen. So we actually valorize the emission gas to generate wealth, which is hydrogen gas, which is very important in this era.
Understood. I can see that the rising of researchers in both developing and focusing on the hydrogen technology. It is much greener and cleaner technology, to be precise, and it is definitely a way to combat climate change in terms of reducing the carbon dioxide emission. So now I think we shall proceed to the Q&A session, and I may have judges. We have Dr. Stephen. You may direct your question. Yes.
Hello, can you hear me?
Yes,
Okay.
I can hear you. Yes.
Okay, first of all, again, thanks for the good presentations. That's a very interesting idea, especially on the usage of the novel catalyst. I'm just worrying because we also have different types of the single atom catalyst that's available in the literature as well as in the industry. So why make you choose this current single atom catalyst that you guys have chosen? What are the properties that can actually enhance the dry methane reforming? So can you elaborate more on this? Thank you.
Actually, we compared a few nickel catalysts in dry methane reforming, and we found out that nickel catalyst supported on HAP has the highest hydrogen yield. So that is a benefit for dry methane reforming to produce hydrogen.
Do you have the data like how high the yield will be if using this type of SSC catalyst?
The yield is about 53% if compared to the conventional catalyst, which is only about 36%. So it's rather high compared to the conventional one.
Okay, thank you.
All right, I think we have another room for another question from the judges. We have Madam Norida and Mr. Chua. Do you have any question for the team SG20 is 020? All right, we have Madam Norida. You may direct your question now.
Okay. It's not really a question. It's just a feedback from me. I was frustrated because I did not see any results of your catalysts that you have chosen. Actually, if you have put in the results of the catalyst on the hydrogen productions, I think your presentations will be much more impacted in relating it to the current topics of this conference here. Thank you.
Yes. In SG20, do you have any perhaps clarification or justification to what Madam Norida has pointed out about your team?
Thank you for the panel for the suggestion. But actually, in our project, we mainly focus on the economic and environmental analysis to prove whether the feasibility of these two novel catalysts is feasible to replace the conventional catalyst in dry methane reforming. So actually, we also consulted some researchers and we consulted the Australian Government Agency Research Centre, which is CRO, about the MOF and SSC catalyst that actually help us to validate the performance of this MOF and SSC catalyst. So yeah.
All right. Thank you, judges, for the questions, and thank you, Team A0020, for your presentation. All right. So I can see that ends your Q&A session. I can see that in the chat box there were no questions asked. May I know why? I mean, of course, simple questions are still questions. It's just to celebrate these young scientists of presenting or talking about their projects, so you can actually ask each other questions and clarifications in the chat box. We can have interactive virtual SEA-GIC session. It's a virtual session, so try not making it to be a one-way thing where you just present a project and have some questions from the judges. We can also interact between these young scientists. Perhaps you can actually have more ideas to improve your projects for the future references or something like that. Yeah. Okay. All right. Okay. All right. So if there's no more question, I think we can move to the next team. Let's welcome team SG20A037 from Universiti Brawijaya to pitch their project. Please welcome. All right, you can start to request control. Yes. It's such refreshing to see how these young scientists are working together with their lecturers to think of a solution to combat climate change and to quote what Dr. Firdaus said this morning. He said about about the fact that we are here, the fact that you guys are here, the 15 finalists here, that you are actually doing something to contributing ideas in terms of combating climate change. All right. So I think I shall call group SG20A027 to start your presentation. You can start to request control, and you may start your presentation. Excuse me, are you sharing your slide?
I'm sorry, my slide. Maybe you.
It's just a reminder. That's fine. Like I said, the technical briefing just now, you have to request control because the organizers actually have your slides ready with us, so you don't have to share your slide. So you just need to request control and release control once you stop your presentation. So can you yes, sorry, can you take down your slide and then all right, and then yes, you can just start request control, and then we'll give you permission for you to start your presentation, and you can actually control your presentation. Can you control your presentation now? You should be able to control your
request control.
Excuse me, you can click on request control on the top.
Yes.
All right. You can click next to play your slide. All right. Okay. Just a reminder that every time you you can start your presentation now. All right.
Okay, ladies and gentlemen and educators, such as a global innovation challenge, we are from Brawijaya University is present. Electrical energy is very near the human in the world, but in Indonesia, its electrical energy is availability in years to years. The energy is demand always increase years to years in Indonesia. Indonesia is need the human electrical energy world consume more than 2,000 kilowatt in 2016 in 500 kilowatt and 70 kilowatt electrical energy. Only result is decreased in 2020. Electrical energy is produced from the microbial fuel cell in the tempe industry in West, but this research is not low voltage, but the results is not effective to implementation in Indonesia. And as number 2 is Ibrahim et al. 2014. It's a microbial fuel cell of which industry waste produce electrical energy, but the result is not effective to implementation in Indonesia. So we are from Brawijaya University. My name is Muhammad Sarifuddin and my partner is Muhammad Karifi Qasim. And Alivia Sinta is our mentor is Professor Amista Laksono, PhD, with give innovation. So, SOA is technology that convert the human waste to the electrical energy. So the electrical energy can be consumed by the human, especially in Indonesia. Ladies and gentlemen, and educator, let's have 2 minutes. Number 1, I call and ladies and gentlemen, an educator, why we have the 3 years training to make the technology axle. The number 1, we need the MFC. MFC is a microbial fuel cell. This technology that convert the bacteria in the society to electrical energy. And number 2, we need the boost converter. And the number 3, DC to AC inverting. Ladies and gentlemen, an educator. Gentlemen, and number 2, we do the program the need analyze with the collecting the material and tool need to make the plan ready to use device 12 liters from the human waste. After that, we the set the human waste to the dual chamber use the set infused. This is a set infused to send the human waste to the dual chamber. This is anode chamber, this is cathode chamber. At the dual chamber, we get the generate, we get the communication, and then we get electrical energy. So the electrical energy we can save and boost convert the boost the voltage is easy, but we need the boost capacity. So in the boost capacity, staff contact society, especially Indonesia. This is the video of the experiment at the Wijaya University. This is our experiment. Our experiment is 12 liters from human waste. We generate to electric energy.
Team SG20037.
Energy.
Excuse me, Mr. Muhammad Sharifuddin. Just now your audio how do I say, it was too loud that we actually could not hear your presentation. I'm sorry to interrupt you, but I think to be fair, I think you should start again, is if that's okay with you, because throughout your presentation your video was a bit too loud. The video that you sent us was a bit too loud. Yes, and we couldn't hear your voice just now. Yes. Is it okay for you to start your presentation, to be fair with you? Yes.
Ladies and gentlemen, you hear my voice?
Yes, now we can hear your voice, and I think we should reduce your audio for the second time. All right.
Oh, okay.
Yes.
I'm trying.
Okay. All right.
Okay.
So I'm so sorry
start.
that you have to
Okay.
restart your presentation because the judges
Okay.
couldn't hear you. We couldn't hear you. So
Okay.
anytime you're ready now. All right. Okay. Good luck for you.
Hear my voice? Okay, thank you. Okay, ladies and gentlemen, and educator from South Asia Global Innovation Challenge. We are from Brawijaya University. Sorry, okay, request, okay. Okay, ladies and gentlemen, and educator from the South Asia Global Innovation Challenge. We are from Brawijaya University is present. Ladies and gentlemen, as the electrical energy is very needed in society and the world, is especially in Indonesia. In Indonesia, is electrical energy is availability in the world. The energy is demand in Indonesia is always increased from years to years. Ladies and gentlemen, and educator, as we know that in Indonesia, as world consumed more than 3,000 kilowatt electrical energy. In 2015, Indonesia has consumed 5,117,000 kilowatt electrical energy. Like the earlier results from the Christine 2012 explain about the electrical energy production from the microbial fossil and the tempe industry waste as the core from the electrical energy. But the result is the low voltage is not effective to implementation in Indonesia. And the number 2 is Ibrahim et al. Ibrahim et al. Is how to convert the microbial fossil on the first industry waste to produce electrical energy. This Ibrahim is a result ineffective to implementation in our society because this is low voltage in Indonesia. So this problem, we give the solution from Brawijaya University. My name is Muhammad Sharifuddin. I'm my partner in Muhammad Kadifi Kasim in Alivia Sinta and the mentor of the Professor Amis Tiolaksono PhD. We give the innovation about ACS-UTP. What is ACS-UTP, ladies and gentlemen? ACS-UTP is utilization, of human waste to make the new and renewable electrical energy based on mobile application and isolated village to achieve SDGs 0.7 2030. Ladies and gentlemen, and educator, what is ACS-UTP? ACS-UTP in here the technology to convert the human waste to electrical energy. The electrical energy is efficient to consume the human, especially in Indonesia as well near the electrical energy. So we believe ACS-UTP is very benefit from the society. we have the material and the tools to make the technology also. The number one is tools. We get the dual chamber, boost converter, transistor, and then transfer step up to increase the voltage from technology also. And then the materials, we need the human waste and the E. coli bacteria and the nutrient board and aqueous. Ladies and gentlemen, and adjudicator, we have the three device planning to map the technology excel. Number one, MFC, microbial fuel cell. It technology to generate bacteria in the society to electrical energy. And number two, we need the boost converter. And the number three, DC to AC inverting to convert DC to AC voltage. Ladies and gentlemen, an adjudicator, what is the device manufacturing stage? Number one, we get the literature study. In literature study, this early research analysis about the theory, microbial fuel cell, application mobile, human waste, and extra. And number two, we get the program need analysis. In the program need analysis, we is collecting materials and tools needed to make the prototype and ready to use in device. Ladies and gentlemen, and the number three, we do the design prototyping. Design is in three design and then three design form. As the reference to build the prototype technology excel. Ladies and gentlemen, an educator and a board of device are planning, we do the device assembly. Device assembly is start with the simple to the complex circuits, the assembly prototype and ready to use device. And number five, we do the evaluation. Okay, ladies and gentlemen, do a vision evaluation. This is true that the device is ready to be applied in society. So this is our prototype 3D from the technology Excel. As we know that technology Excel we make in the laboratory of mathematics and science in Brawijaya University. This is our product prototype. So now our product is ready to implementation in society, especially in Malang, Indonesia. How to generate human waste to electrical energy. So in here, we put the human waste in the chamber. This is a chamber. So if after we input the human waste in the chamber, we send the human waste to the dual chamber. It is dual chamber. This is chamber anode and a chamber cathode. And the chamber anode is a positive ion and the ion, and then cathode is a negative ion. So in the positive ion and negative ion is communication is the map the electrical energy. In here this produce electrical energy, so we save and the boost converter. In here boost converter to save electrical energy. After that we need the DC to AC inverting. But a DC to AC inverting can consume the electrical from the society. After that, we can put electrical energy at the stop contact, so the society can use electrical energy from the human waste. Ladies and gentlemen, and educator, this is our video experiment in the laboratorium, Faculty of Mathematics Science in Brawijaya University.
All right, thank you, Team SG20A03.
Okay, ladies and gentlemen,
sorry.
This is our video experiment. This 3 liter from the human waste we can generate from the electrical energy. So they get the efficiency as 95%. So we believe human waste is more potential in Indonesia, especially in the world in the general, can convert the electrical energy. Ladies and gentlemen, an adjudicator. This is a device mechanism to turn on the lamp. This is our experiment in my laboratorium. This is, we need the salt and then the human waste. This is all human waste, ladies and gentlemen. Human waste we generate to electrical energy. We need, in here, we can turn on the lamp. Turn on the lamp is every 2 weeks. We can turn on the lamp in 2 weeks. This is our experiment. We need the material like the boost converter and extra. Okay, and then the how to device application. So in here we make the device application. Why we make this? Because it can more easy use the people. As we know that human waste is very not good the aroma, so we need the application to make the technology excel. Okay, this is the IoT mechanism. In here, this is our IoT mechanism. Number one, the application is the request data from the Firebase. Ladies and gentlemen, Firebase is like the bridge between the technology Excel and then the application Excel. So the application can the request data like the bridge Firebase and request data in the in the technology Excel. Technology Excel it get the microcontroller Arduino Uno. Microcontroller Arduino it can the send data back to the Firebase, and then Firebase send data to the application, and the application can show about how much substrate in the technology is low. We can on off automatically. We can know temperature from the technology low. Ladies and gentlemen, in our results, in our technology, we get the 4 stakeholders to develop our research. Number one, the Ministry of the Energy and Mineral Resources in Indonesia to promotion our technology excel. Number two, the academies, especially in Brawijaya University in Indonesia. And number three, society in mind people to use technology excel. And number four is community to support society to use technology excel. Ladies and gentlemen and educator, so excel is the device that convert the human waste into electrical energy. This base application mobile and 3 liter of human waste, we can generate 22 volts with this 90 watt of efficient level. And ladies and gentlemen, Axelois can fulfill electrical energy needs in the isolated village, and then it support international program on SDGs Point 7 2030. Ladies and gentlemen, so try not to become a man of success rather than becoming a man of value. Thank you for your attention. And we can beg a moderator. Wassalamualaikum warahmatullahi wabarakatuh. This is our patent letter from Brawijaya University. Thank you.
All right, thank you for such a brilliant presentation about your project. Converting human feces into energy is something that have yet to be commercialized, I believe, right? And just to ask you a simple question, how long did you take to do this research? Basically, how long did you take to do this research? Basically, from generating energy to developing the apps that could actually monitor the temperature of your Excel. Yes. So how long did you take to Mr. Sharifuddin, can you hear me?
Okay, thank you. Okay, thank you, Miss. How long we generate electrical energy? Yes, and then in here we research in our professor Mr. Laksana PhD. We do the research is 1 month. It's 1 month. We do get the study literature. We search a journal about what the human waste bacteria in our technology. So in bacteria, electroactive bacteria is can generate from the electrical energy. So with this journal, we research, we observation is our city in Malang, Indonesia. So in Malang, Indonesia is very much the human waste. So it's not effective in not use and the other electrical energy. So in here we give the innovation to make the absolute to implementation technology and human waste to convert electrical energy like that. Maybe my friends as my answer.
All right. Okay, such a brilliant presentation, I would say. I think we should proceed to the Q&A session. I could see Dr. Steven is ready to ask his question. You may direct your question, Dr. Steven. Yes.
Okay. First of all, again, thanks for a very good presentation. So it's refreshing to see the application of human waste as an energy source, and I especially like the idea of how you link it to the IoT's Internet of Things, which is the current trend nowadays. Before I go to my question, just wondering, because earlier you show us that you have actually had 2 other team members working on this project, right? Why are they not presenting? Just curious for this one. Because I see you only the one presenting, right? But earlier you show you have 2 other team members. So any reason why they are not presenting together?
Maybe my friends and answer your question.
Oh, I see. Okay. My question will generally be, because this is a good idea and it shows that you actually can get a very high efficiency, which is about 95%, right? So can you elaborate more on this? How do you come out with this 95%? Because as far as I know, microbial fuel cells, none of it has such a high efficiency. So can you just explain how you achieve this high efficiency? Thank you.
Okay, sir. Thank you for your question. I will maybe answer your question. 95 efficiency percent is we need of the DC to AC inverting. It is voltage for DC to AC inverting. We buy the DC to AC inverting is get 50 efficient. In here I'm to form the voltage and form the daya and etc. So we get the produce, we get the 95%. Maybe my friends from biology can add my answer.
Yeah, thank you for your question, Mr. The efficiency 95%. So we use the bacteria in the feces is we added a nutrient broth. So the metabolism of bacteria is can very well. So it helped to produce high voltage from this instrument.
Okay, thanks for the answer. Thank you.
All right,
As
and we have another question from our judges, Madam Nurida. She's sent her question in the chat box. She asked that, have you calculated on the cost per unit to build the new working mobile unit? Have you can actually see her question in the chat box. Yes.
Okay, thank you for the question. So it is about how much the cost for produce to develop this instrument. So here to develop the mobile application, we just need for no, it's just around 1 million rupiah. So it is very cheap compared by when the government electrical company. Maybe my friend from instrumentation can add the answer.
Okay, thank you, Miss. And for a question, I want to add my answer, my friends. And it's very cheap. It's our technology is like it's 1 million to buy every material and every tools to convert the electrical energy. So we believe it technology is like it's very effective, efficient, and to implementation in Indonesia. In here, I will give IMEC to develop. This is our application. This our application can control. I can control the technology slow on off automatically. We can control our voltage and substrate in technology slow. So we believe our technology is our result is effective and accept to society implementation like that. Maybe my friends and my answer.
All right. Thank you, judges, for the questions, and thank you, Team SG20A037, for your presentation. It's such a brilliant idea project. Maybe we can, in the future, we can do something in terms of to build it, to commercialize your project. From pieces, human pieces, to energy. Yes, that's very. I mean, who would have thought to use human pieces to convert energy? And we actually have another question from Mr. Leong. He asked, as human waste can differ based on the different nutrition and eating habits, do you characterize the human waste beforehand? Yes. Do you characterize human waste beforehand? Do you mind to answer this one short question?
Yes, thank you for the question. So how do we characterize the bacteria in the human waste? So here we are not using a single culture bacteria, but we use the whole community of bacteria to convert to produce a renewable and electrical energy. So here we are not characterizing the bacteria, the whole community to produce the electrical energy. Thank you for your question.
All right. Thank you so much for the clarification of the questions, and that actually marks the end of our first pitching session. And we'll be actually entering a 5-minute short break. And let us entertain you all with a short video about Universiti Teknologi PETRONAS. Please enjoy.
come in search of answers. To those of you who have come in search of answers, seeking inspiration and looking to achieve your aspiration, this is the place where you will learn to find the answers, where you will be motivated to discover your inspiration, where you will be propelled to realize your aspirations. With today's global challenges, the role of the engineer, the scientist, and the technologist is transformed from being the technical innovator into being the agent of global change. Our world-class resources and faculties, our cutting-edge facilities, our global partnerships with leading universities, our strong network with industry for internships and job placements, our worldwide research collaboration. These are the inspirations and the opportunities at UTP. Here, we nurture the analytical skills and intellectual capabilities of all who walk the UTP path. Here we culture the ethics and the attitudes that will shine in the real world. Here we expose ourselves to what it truly means to be human, to be a valuable part of society, to be the empowered people, the game changers, who will light up the path towards a better world and change lives for the better. At UTP, the torch is firmly in your hands. So hold it up high and let us together light it and let it burn brightly. Join us to seek inspiration and achieve your aspiration towards global prominence.
All right, just to recap the first pitching session just now, we have project about a biodegradable plastic bag, and then we have about generating hydrogen gas or basically energy from using seawater, and then we also have generating energy from human feces. Such refreshing ideas in terms of alternating to renewable energy. We have more options in terms, and this research is that has been done by these young scientists. I hope it can be future we can actually develop it or commercialize the ideas of these researches itself. All right, so okay, now I think we can proceed with the second pitching session, and I shall call upon team SG20A045 from Universiti Teknologi PETRONAS to begin their pitching session. Please welcome. And you can start to request control and unmute your mic to start your presentation and whenever you are ready. You can request control.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, Kak Ain.
Okay, I would like to confirm that my colleagues are here, Muhammad Amirul Amin. Okay.
Yes, I'm there.
Okay, let us start our presentation today. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning I bid to the respectable judges, SEA-GIC 2020 organizing committee, and fellow audiences. There is an old Chinese proverb that says, good things come in pairs, just like yin and yang, male and female, and the list goes on as we realize that a combination of two things may work as a wonder. My colleague Muhammad Amirul Amin bin Muhammad Shukri and me, Muhammad Amirul Ashraf bin Muhammad Razib, under the tutelage of our supervisor, Dr. Khairul Azhar bin Jumriya from Universiti Teknologi PETRONAS, would like to add to the list today by introducing novel composites made up of colinium-based amino acid ionoliquid and metal organic framework that may solve the compelling climate change issue through fundamental research on carbon dioxide adsorption properties of the composites by employing dry lab approach in our work entitled choline-alanine ZIF-8 Composites, New Horizons of Sustainable Carbon Capture Technology.
Combat against climate change as well as impact is one out of 17 sustainable development goals that has to be achieved by 2030. Anthropogenic carbon dioxide emission from the burning fossil fuels from the various sectors is the main perpetrator of this problem and has devastated our beloved Mother Earth climate. Melting of polar ice caps, rise in seawater level, and increase in global temperature are the major climate issues that need to be addressed by employing highly sustainable and energy efficient carbon capture and sequestration technology. Despite the mature status of conventional carbon capture and sequestration technology that utilize chemical absorption of carbon dioxide by using acanolamine have been proven to suffer from the acanolamine toxicity and corrosive properties that can cause irreversible damage to nature. Combined with the high regeneration enthalpy of the acanolamine itself that require massive energy input, this issue has become a major dilemma that require swift action from researchers all around the globe. By adhering to the several fundamentals of 12 green principles, our group from the Universiti Teknologi PETRONAS opted for dry lab research by conducting molecular dynamic simulations discover a breakthrough in developing state-of-the-art carbon capture technology of choline-alanine zeolitic imidazolate ZIF-8 framework composites. Ladies and gentlemen, next slide.
Excuse me, organizer, I don't have a request. Can you approve my request?
Can you request control one more time?
Ladies and gentlemen, we have conducted a molecular dynamic simulation to determine the free solvation energy of carbon dioxide inside choline-alanine zeolitic imidazolate framework A composites of different weight ratio at various simulation temperature and pressure. Then, the information from the free solvation energy simulation was used to calculate the solubility and absorption enthalpy of carbon dioxide inside the choline-alanine ZIF-8 composites.
Ladies and gentlemen, the culmination of this project was possible due to the prior molecular dynamics simulation research paper that was published in the Journal of Hazardous Material that studies the carbon dioxide and hydrogen sulfide adsorption properties inside choline-based ionic liquids and isoreticular metal organic framework composites. Inspired by that works, the development for these novel composites was executed by impregnating extremely hydrophobic and thermochemically stable zeolitic imidazolate framework 8 pores with choline alanine, a benign and biodegradable choline-based amino acid ionized liquid that can be synthesized from renewable sources. Impregnation of choline alanine inside the zeolitic imidazolate framework 8 modified the nanocageous environment of the pores, leading to the augmented absorption of carbon dioxide. Apart from the pore modification executed by the impregnation of choline alanine, the hydrophobic properties of zeolitic imidazolate framework 8 is another crucial property that ensure no interference from the incoming water vapor during the carbon dioxide absorption process and jeopardize the integrity of the composites that may lead to the reduce in absorption capacity of the composites. 3 different weight ratio of choline alanine ZIF8 composites were used in this project. Free solvation energy of carbon dioxide simulation inside each composite was carried out at 2 different temperatures and 5 different pressures. In the span of 2 months, involving 30 different simulation systems, we discovered that 0.8 choline alanine ZIF8 composite at 298.15 Kelvin and 10 bar display the highest carbon dioxide solubility at 0.079 mole per liter bar with the extremely low absorption enthalpy of negative 1.68 kilojoule per mole. These simulation results gave a glimpse of hope for the development of carbon capture and sequestration technology that has high performance with minimal energy penalty for the regeneration of the composites. Esteemed judges and fellow audiences, the time is ticking, and after 5 years since United Nations set the Sustainable Development Goals to motion, we have yet to come to a sustainable solution that can reduce carbon dioxide emission as well as mitigating the climate change impacts. Nevertheless, by resorting to molecular dynamic simulation, which is a component of the dry lab, both research time and research costs can be reduced substantially. Furthermore, through molecular dynamic simulation, our work has shown that mild reaction condition in capturing carbon dioxide can be achieved by using newly developed choline alanine ZIF8 composites. With the state-of-the-art choline alanine ZIF8 composites, sustainable carbon capture and sequestration technology that boasts efficient energy usage can be achieved within the next few years as we push forward in our endeavor of making this world a better place for future generations. We would like to extend our gratitude to Fundamental Research Grant Scheme and Yayasan Universiti Teknologi PETRONAS for the financial support throughout our research. And we are honored to have any collaboration offers that can further enhance the fundamental research conducted in this project. That's all from me and my colleague. Thank you very much.
All right, thank you, Team SG20A045 for your presentation. And I think we shall now proceed to the Q&A session. We have Dr. Stephen. You may direct a question.
Hello. Okay, so once again, very good and wonderful presentations. So this is our first time looking at these composites for the carbon capture and sequestration system. So it's very novel idea. So my questions will be, you have shown the data of the carbon dioxide absorption process. So I'm wondering, how about its desorption capability? Once you have absorbed the catalyst, so what you're going to do with these composites? Do you mind to elaborate on that? Thank you.
Okay. Basically, we still don't have, we are conducting fundamental research on studying the absorption properties because, as you know, now the conventional carbon capture technology that utilize alkylamine solution has suffered from a large regeneration enthalpy. Therefore, first in our project, we prioritize on finding the lower absorption enthalpy. And basically, what we can conclude from this research also if we have low absorption enthalpy, that means the desorption enthalpy also would be low, and thus mild condition for desorption as well as further usage of carbon dioxide that being captured can be studied after in further research.
Okay, thank you. Thanks.
All right. We can have another question for the Q&A session. Maybe the judges would like to ask question. We have a question from Madam Nurida in the chat box. She asks, have you actually conducted any lab testing to validate your molecular modeling prediction on the carbon dioxide absorption and desorption potential? May you elaborate on this question?
Yes, thank you. I would like to answer that question also. Basically, in this, we have not conducted yet any experimental work to validate the molecular modeling prediction. Nevertheless, before we are doing simulation, before we are doing this research work, we also conducted pre-simulation that is crucial to ensure that we can authenticate our modeling prediction. For that, I would like to pass to my friends, Muhammad Amin, to answer that, to further elaborate these questions.
All right, thank you, Amirul Ashraf. Okay, for the pre-simulation method is that there's two methods that we use. First is we use to predict the density of choline alanine from 298 Kelvin to 373 Kelvin, and then compare of the simulation density with the real density, and ensure that the percentage of the deviation of the density is around 50%, 5%, sorry, 5%. And the second method is we determine the solvation energy of CO2 inside different water model. And yeah.
Okay, so to recap what my friend said, that we conducted two stages of determining the reliability of this molecular dynamic simulation. First is that we conduct the density prediction for the ionic liquid choline alanate, and the second one is we conduct the hydration-free energy carbon dioxide inside different water model in the choline alanate, and based on our finding, both of these simulation yield deviation value that less than 5%, which make it reliable, which make it this molecular dynamic simulation is produce reliable and also accurate results.
All right, understood. All right, thank you, Team SG20A045 for your presentation. And I actually have a very simple question to ask. Do you mind to share with us how does your molecular dynamic simulation actually would contribute to the research? Do you mind to share a bit about it?
Well, basically, as I mentioned in my presentation, as we nowadays, for example, if you want to develop new carbon capture and sequestration technology, we face with, for example, the first problem is screening process. As we know that we have a lot of potential adsorbent and also potential adsorbent. Nevertheless, by using molecular dynamic simulation, that can actually reduce reduce the cost of research, as we don't use a real chemical compound, and also but we don't compromise on the accuracy, as we use the suitable parameter that can actually represent the model very well. And then that's one of the advantage of the molecular dynamic simulation. And as we narrow down the screening process, thus we can focus more on the further research work. For example, determining, like Dr. Steven Lim said before, after my group established the research work on these fundamental works, then further analysis on further research work on researching the desorption enthalpy and what is the mechanism of the adsorption that can actually contribute more to the development of this carbon capture and sequestration technology.
All right, very much understood. Thank you, Team SG20A045 for your brilliant presentation about molecular dynamic simulation, and thank you judges for the questions, and let us. I think we should welcome the next team, Team SG20A014 from Universiti Malaya to pitch their project. You may start to request control. Right.
I cannot read the where's the button.
Hello?
Hello, yeah. Can you hear me?
Yeah, I can hear you, yes.
I cannot find the button.
Button for for camera, is it?
No, for the
request control.
Yeah, exactly.
Is on top. Yes.
Is on top. Okay.
Team SG20A014. Do you have any problem? Yeah. It's supposed to be on top of your. I mean, it should be on the same line with the mute button and camera button. You should find another button label request control.
Wait a second.
All right.
Is it there, Nick?
Actually, you mind to press it for me?
Yep.
Because I cannot find it from my side.
1 moment.
I see. Yes, perhaps your team member could request control.
Oh yeah, sure.
Okay, I think I have it now. Nick, do you have it?
No, I don't have it.
Okay.
Okay, can you press for me, Shamali?
Request control.
All right.
Is it okay now?
Yeah. Nick,
all right. Okay, you may start your presentation whenever you're ready.
Greetings, this is me, Sharmali, and my partner Nick. We are from the University of Malaya, and today we are bringing out our idea on the plastic bin. So we made plastic, and now we are drowning in it. The miracle material has made modern life possible. However, the victim of this success appears to be life on Earth. We are addicted to plastic. But how did the world become so dependent on it in the first place? It is present in almost every aspect of modern life, from water bottles to aircraft. They were so cheap, we began to make things we never intended to keep. Decades later, more than 400 million tons of plastic produced each year is discarded within minutes after purchase. Humanity's relationship with plastic is rather schizophrenic. We see it on our streets, and rivers and lakes, on our beaches, and even in our deepest ocean. Part of the problem is that people are at times still unaware of the scale of the problem, the full extent of the devastating damage being done to our planet by our petty, neglectful action. The idea of development and economy has moved us far from this reality. It's time for us to make a more mature decision. So what could be another of mankind's latest revolution in the fight against plastic? Our answer today would be the plastic bin.
Next.
I'm already on the next page.
Okay. In 2016, scientists has found an interesting bacterium called Ideonella sequences that can digest plastic, specifically polyethylene terephthalate or PET. The bacterium was found to be able to do this because it has a specific type of enzyme dubbed PETase for its ability to break down PET into MHET and finally into terephthalic acids and ethylene glycol via hydrolysis. Next. The enzyme produced by the Ideonella sequences is at very low concentration, and it is in fact the time for the reaction to occur, and the enzyme is hardly to be found. The synthetic PETase is synthesized to mimic the degradation of plastic. To achieve that, PETase is synthesized in the lab via native chemical ligation, where all the fragments of small amino acids are assembled to become huge structures of the enzyme, and the screen shows the structure of the PETase. As I can recall, the structure is built up by the small fragments of the amino acid to become like this. Next. However, as we notice, this enzyme is thermally unstable. The instability of the enzyme is caused by the lack of the hydrogen bond inside the major site of the core, since this enzyme belongs to alpha-beta hydrolase superfamily. Next. Hence, protein engineering knowledge is applied to this enzyme to mutate the structure. To mutate this enzyme, histidine and aspartic acids are introduced to ensure that the hydrogen bomb is formed, hence the structure is strengthened. Next. The bacterium, however, has several disadvantages that make it unsuitable for use. They produce endotoxin, require a rich carbon source to grow, and their overly rapid growth present a threat when leaked into the environment. Therefore, we engineer a type of microalgae, Chlamydomonas rinhardtii, to express the PETase enzyme. This microalgae is much more environmental friendly solution and is generally recognized as safe. The microalgae does not require organic carbon sources under phototrophic condition, nor does it produce endotoxin.
So since this idea platform, we came up with plastic bin. We use our microalgae in a microbiofuel cell to further treat the PET degradation and produce a small amount of electricity. To picture, the plastic bin is a simple setup that consists of two chambers. In the top chamber, the PET waste is shredded into small chips and put together with our PETase balls. The bin is then covered and the reaction are allowed to proceed on its own. In our system, a layer of agar culture which contains the alga Chlamydomonas rinhardtii that holds the PETase enzyme is grown on a surface of polymer balls. The agar is covered with a layer of alginate to protect it from any possible scratch damage. These polymer balls are brought in contact with the PETase waste in the chamber at the top. Principally, the plastic bin takes advantage of three reactions, the first being the use of PETase enzyme to catalyze the degradation of PET. In this step, the PETase balls are brought in close contact with the PET plastic chip and they can react to give terephthalic acid and ethylene glycol. And because both the products are denser than water, they would sink through the wire mesh into the fuel cell below. The next set of reaction happens in the lower chamber of the cell. In the microbiofuel cell, carbon plates are arranged alternatively and they work as a working and counter electron. They are arranged alternatively close to each other to reduce any solution resistance. The reaction here uses the bacterium Daphlea cerohantensis to metabolize terephthalic acid into carbon dioxide, water, and small amount of unmetabolized byproduct. Similarly, a third reaction uses a mixed consortium of anaerobic bacteria to break down ethylene glycol into mainly carbon dioxide and water again, and again a small amount of less but harmful byproduct. The working electrodes, the anodes, are coated with a layer of conducting polymer P2PSS that contains either the Daphlea cerohantensis or the mixed consortium of anaerobic bacteria. A layer of alginate is again used to protect the agar layer. Both the processes here, Daphlea cerohantensis and a mixed bacteria metabolize the terephthalic acid and ethylene glycol, using them as a carbon source for growth. Part of the energy generated in this process is stolen by the carbon collector as free electrons. Both the processes produce electrons which flow through the carbon collector and then the cathode to produce electricity, which is used to power an indicator light. The electricity here is used as a signal to monitor the health of our system. A drainage valve is positioned at one side to remove spent water electrolyte once the reaction is completed. It is outfitted with successively smaller sieves to catch any possible unreacted PET microplastic so that they do not contaminate our environment again. The spent water electrolyte will be filtered through a simple sand filter before disposal. This modest concept and setup can break down PET completely and sustainably while being easy to operate and does not require constant supervision. It has relatively simple construction which will ease any maintenance work, and the added advantage of being self-sufficient, they do not need energy input. So it can be envisioned that this system are widely installed in residential homes and areas in school, where responsible citizens can play their part by safely disposing PET waste in them. Our system can serve as a complementary effect to reduce plastic waste and keep them out of our nature, slowly but surely. Thank you.
All right, thank you, Team SG20A014 for your presentation. And now I think we shall proceed to the Q&A session, and I shall invite Dr. Stephen to direct your question.
Hello. Okay, so good afternoon, everyone. So again, that's a very interesting and innovative ideas from the students. Okay, so my questions will be, since I saw from the slide that you have shown, you're also generating carbon dioxide as a byproduct. So I'm just wondering, what do you actually deal or use this carbon dioxide for in your system?
We did not think on what to do with the carbon dioxide. We wanted to break down plastic, but yes, we realized carbon dioxide is again released in the electrolyte system. But the damage that we have done to this world by creating plastic took a long process, and to reverse those damage that we have done will definitely take a longer process and even more effort to clarify all the wrongs that we have done. So in that case, probably the process of completely degrading it will take more further reaction and further research. This carbon probably can be used in the other carbon capture systems that was proposed or that's already existing, such as MOF and other ideas to remove the carbon dioxide from our atmosphere, from our ecosystem. So it's a long process, and we are halfway through it. The process can go on with further research if we really want to put our effort to eliminate this plastic from our environment. So it's a small step at the beginning, and it has a promising flow if you really want to do it.
Okay, noted. Just one more question. Basically, how long will it take for the PET bottle to actually degrade completely for this system?
Nick, do you want to answer that? Or
May I answer? Yeah. Okay, we notice the question will come. So the thing is that PETs will degrade plastic approximately about 1 month before modification is applied. So by applying protein engineering, as you can see, why we do that is that because of the hot climate, because of the hot weather of Malaysia, therefore the enzyme is like thermally unstable. So because we notice that thermally unstable property, therefore we trying to figure out things that, and then we apply the knowledge of protein engineering where we introduce histidine and aspartic acid to strengthen the structure. So in order for a reaction to occur, before the modification, it takes you 1 month. After modification, it shortened to 7 days for one plastic bottle to degrade for PET by the enzyme. Yeah.
Okay, thanks.
Yeah.
Thank you.
Sure.
Yeah.
All right, thank you, Dr. Lim, for your question. So we haven't heard from Mr. Chua for so long. Perhaps this time, Mr. Chua, do you have any question to the team? You may direct your question.
Yeah, just raise a hand shortly. Maybe you don't notice it. A quick questions for the scale up of this mechanism, as you mentioned, to the citizens. What challenges you anticipate for the so-called for the people usage widely in the environment?
Our idea as a prototype, we envision this as a bin that will be placed similar to our recycle bins and it's already in factories. So we have to bring the awareness, if it made to a commercial state, we have to bring the awareness on how, instead of disposing plastics into particularly PET into the recycle bins, it should be brought into the plastic bin where they would like by a simple action, they're actually reducing plastic. Maybe not a whole chunk of it, not to the amount that we already have, but one by one at a time. So bringing it to the people would not be a very big challenge if we bring out the awareness correctly.
May I add up? Okay. If you can see the advantages of this plastic bin, it's actually with no minimum monitoring as well as no like it stated that it's self the energy is generated by the system itself. Therefore, I think in terms of energy and in terms of monitoring, there will be no such manpower or no such cost in that, because the machine is only built by, the cost is only built up by the machine itself, but the energy is generated by the machine, so that we do not have energy to supply to that machine. Where where the energy is come from is it is come from the electron being produced inside of the system. So yeah, plastic bin can allow to be run by its own with only minimum monitoring, and the energy is generated by itself. Thank you.
Thank you, Nick.
Thank you.
Yep.
Thank you.
All right, actually, we have another question from Madam Nurida for Team SG20014. She's asking about how robust is the microorganism that you're using in your project. Do you mind to clarify this question? You can find this question in the chat box.
Okay. How robust this is? Particularly, we zoom down to PET because we want to eliminate, that is very common, very major. It's in our plastic bottles. Everyone uses it. There's a lot of type of plastic, but this is one that is majorly affecting. So that's when we zoom in into PET, and then the PET is enzyme, which is the iodonyl saccharidases. But however, the system itself is a modular system. Through research and years to come, if there are more bacteria, enzymes, the more proven enzymes that could degrade plastic, more bio research on it, the system can be easily changed. It could the enzyme could be modified, the system can be modified to hold and also degrade different types of plastic. So it's a very robust structure on its own. The idea moves, it's promising. We just need research and the passion to bring a better environment in the future.
All right, thank you Team SG20A014 for your presentation, and thank you judges for the questions. And I think that was a very brilliant presentation about utilizing microorganism in what we call that, substituting in producing plastic. So I think we shall now welcome the next team.
Thank you.
Team SG, all right, thank you. All right, Team SG20A052 from Universitas Asia Yogyakarta to start your presentation. Please welcome. Team SG20A052, you may start your presentation. Don't forget to click the request control button. All right, done. All right, so you may start your presentation whenever you are ready.
I'm sorry, where is the presentation?
You can click next to play your slide. Please be noted that only one person can do the request control button. It cannot be two people simultaneously, so it has to be one person at a time. So perhaps one of you, okay, now play your slide. But you may start.
Okay. Let me start. We are the first generation to feel the effect of climate change and the last generation who can do something about it, Barack Obama. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today, we want to present our idea about combat climate change, which is artificial tropical algae forest, a smart solution to combat climate change. First, let me introduce our team. I am Panji Agung Nugroho as the leader. And then Syarifah Tiara Nurintan. and then Gradia Martin Jeti Pramareti, and why? And then Miss Anissa Kumaira as our advisor. I'm sorry, Miss. Is this why this is just keep running? I don't know. Yes. Hello. Can anyone hear me?
Yes, yes.
Uh,
Mm-hmm.
wait.
Okay,
There
okay,
is
sure,
some
sure.
problem
All
with
right.
this presentation.
Okay, all right. And you click next.
Okay.
Mm-hmm. Wait, may I know what's the problem? You can request control.
Okay.
All right. All right.
Can we continue? Okay.
Sure,
We
sure.
start from the beginning. I'm sorry.
Of course, of
One,
course. Okay.
two, three. We are the first generation to feel the effect of climate change and the last generation who can do something about it. Barack Obama. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today, we want to present our idea to combat climate change, which is artificial tropical algae forest, a smart solution to combat climate change. First, let me introduce our team. I am Panji Agung Nugroho as the leader, and then Syarifah Tiara Nurintan, Gradia Martin Jati Pramareti, and Miss Anissa Humairah as our advisor. We are a biotechnological student of UNISA and we are from Indonesia. Next.
Higher levels of CO2 in the air cause the Earth's surface temperature to increase, resulting in global climate change. If you don't take any countermeasure, the climate change that will happen will get worse. Next. The sea has great potential to overcome this problem, one of which is the algae forest. Coal forest has great potential because it has a good ability to absorb CO2. However, tall forests can only grow in cold water areas to not survive in tropical climatic conditions. Next. The opportunities for developing tropical marine algae forests are huge because equatorial regions such as Southeast Asia receive sunlight all year round. Therefore, we want to use the same mechanism in tropical areas using algae from the species Sargassum sp, which can grow on the coast of tropical seas. In addition, Sargassum sp has advantages such as a high growth rate and is more resistant to rising seawater temperatures. Sargassum sp can produce high biomass and contribute to climate change mitigation through a high carbon storage level of 30.2x2%. With the right system, artificial tropical algae forests can contribute significantly to reducing CO2 levels in the future. Next.
Next, can anyone hear my voice? Okay. Next is about the purposes. The main purposes of our project, which is artificial tropical algae forest, is to absorb CO2 from the air naturally with a simple and cheap system, which can also then be used for other purposes. Next. Next is about the material. The materials that need to make the artificial algae forest are pea root, football, flagstone, and seedlings of Sargassum sp. Next. Now we're gonna talking about a method. There are 4 steps we do in our method to produce artificial algae, which is first material preparations, second making a first framework, third forest placement, and fourth as the last method is routine maintenance. Next. Now as what I mentioned before, the first step is material preparations. The use PE rope uses a rope with a diameter of 8 to 10 mm so that the forest structure is strong. The stone weight used can be made of natural rock or made using cement by a local community. The algae seeds come from the cod algae of Sargassum sp. Next, as second step, is about making a forest framework. The forest framework is made with roughs and area 10 by 10 meters and height of meters of 5 to 10 meters depending on water conditions. The distance between the vertical roughs is 50 to 70 centimeters to maximize the light and water flow for algae growth. The frame is then installed with a ballast weight and float pole to form a vertical structure. Mature algae seeds that have been cut are implemented in the forest skeleton. Next. Then is the third step, which is forest placement. The finished forest is taken by boat and then placed in the selected area. The algae forest area must be in the area without coral reefs so as not to damage the natural ecosystem. And area was also selected where the ships did not pass through. The area is also expected to have a fairly calm current. Next. No, we talking about fourth steps, which is the last step in our method, is about routine maintenance. Algae forests require regular monitoring and maintenance, such as cutting down overgrown algae, and then can be used as raw material in the food, pharmaceutical, cosmetics, feeds, fertilizer, textile, paper, and so on industry. Thank you. Next.
Photosynthesis is the main mechanism of this forest algae in reducing CO2 level. Algae cell will absorb CO2, water molecules, and sunlight to produce glucose and oxygen. And then the glucose molecule is converted into another form of carbohydrate, in this case alginate. In fact, Sargassum sp is one of the algae that has a high carbon storage level. In 2015 research showed that Sargassum sp can absorb CO2 as much as 2,202 tons per square kilometer. Based on the data, if we cover only 1% sea area in Southeast Asia, we can remove about 11 million tons of CO2. With the system that we create, this algae forest is expected to maximize the absorption of CO2 from the air. Artificial tropical algae forests are a smart solution to tackling climate change because the system has several advantages. First, it's minimal maintenance. This system uses live biological agent in the form of microalgae, and human's role is only when planting, placement, routine care, and algae will naturally absorb CO2 by photosynthesis. Next, it's cheap and simple. With an estimated cost of around 4 to 5 million rupiah or 200 to 300 US dollar per forest unit, it is considered cheap because forests can function for a long time as long as the forest structure is still functioning properly. The only needed tools, like we mentioned before, are PE ropes, float balls, weight stone, and algae seedling. The weight stone can use natural stone or be made independently by the local community, and the algae seedling can use excess algae from previously grown algae forest. Next, it's multifunctional system. Apart from its main function as a CO2 absorber, artificial algae forest can also be used as an artificial ecosystem to restore the wealth of marine ecosystem that were previously damaged. The algae forest can function as a shelter for small marine animals. Algae forests can also remove pollutants such as excess fertilizer from the water. Algae forests can also be used for economic activities such as oyster and fish cultivation with certain limitation. With strict regulation, the local community can use excess algae for various activities, and the algae forest can use for tourist attraction. Next, it's creating new jobs. The system is simple to talk easily to general public in coastal area to run this program together. Local people can be employed as forest supervisor in their area. In addition, planting and making forest frames must be done manually so that local people can be employed, so the algae forest will give direct or indirect positive impact to the local area. Next, it's future development. The development of these algae forests can be done by genetic modification of the algae to grow faster and more resistant to temperature increase. It is also possible to develop another form of algae forest so that it can be more efficient. And it is also possible to use another type of algae that's suitable in certain area. And this is the video of our prototype, which is there is a float balls, weight stone, PE rock, and the algae. And the algae forest in this prototype is floating on the water. And the last from us, let's make a simple thing do a great thing. Thank you.
All right, thank you, Team SG20A052. I think we shall proceed to the Q&A session first, and we have Dr. Steven to ask question. You may ask your question.
Okay, so good afternoon. Again, good presentations and very interesting idea about growing an algae forest in the marines, in the seas. So just have a question because I see that this algae forest basically you are growing it in the vertical format, and of course we all know that the algae requires ample of sunlight to actually produce the bioproducts. So I'm just wondering if you place it vertically, right? Basically, the sunlight exposure will be mostly on the top of the algae. So how about at the bottom? So will the sunlight exposures reduce affect its production also? Can you elaborate on that? Thank you.
Okay, thank you for the question. How about the bottom part of the forest? That's why we use a macroalgae in the form of sargassum, because sargassum has a system of nutrient transportation. So the upper part of the forest can do a photosynthesis and then transport the nutrient to the bottom part of the forest. And because of that, we can we do a routine maintenance like as cutting an excess algae in the upper part, so the bottom part could also receive sunlight. And because we make the forest in distance of 50 to 70 centimeters, we think that that's a good distance to maximize the sunlight to receive the bottom part of the forest. Thank you.
Okay, thanks for the answer. Thank you.
All right, and we have another question from Mr. Chua. Mr. Chua, you can ask your question.
Hello, good presentation. To extend from the question from Dr. Steven, have you considered to shorten your algae forest to a different length to understand the efficiency against the light absorption, so that your square area of the efficiency will be higher, no?
So, can anyone hear my voice?
Yes,
sure.
Okay, thank you for the questions about the length of the algae forest that we make. We make the algae forest about in a vertical structure for which can accelerate and increase the absorption of CO2 by photosynthesis. So if we make the length more long or more short than what we planned before, we probably could make the photosynthesis not good enough, and we need more research to take a test about the photosynthesis, about the CO2 absorptions in the algae forest. Thank you.
Thank you.
All right, thank you for the clarification of the questions, and we actually have another question from Madam Nurida. She actually praises your team. She said that congratulations, as this project is really a green idea. And her question is that, have you tested the feasibility of your vertical algae forest in the lab for the carbon dioxide reduction? You may
Okay, thank you for the question.
All right.
We adapted from the method of farming seaweed, but there isn't a vertical system. So why we want to choose this vertical system? First, we inspired by the kelp forest. So the kelp forest has first it's a vertical, so the marine animal can use the forest to act as a shelter for small animal, and because the vertical structure, it will function as it will maximize the absorption of the CO2. So it's not only on the upper part of the water body, so it will use most of the water in the forest structure. So it will maximize the absorption of sunlight, CO2, and marine acidity that cause seawater acidity. Thank you.
All right, thank you, Team SG20A052, and thank you, judges, for the question. Your project is very simple yet very impactful as well, and I like how your project is a mix of reducing carbon dioxide as well as could be used as a tourist attraction. Is yeah. All right. Okay, thank you for your project. All right, now I think I shall welcome your team SG20A015 from University Science Malaysia to pitch their project. Please welcome.
Hello.
Hi. Yeah, you can request control and you may start your presentation anytime you're ready. Okay.
Is my request has been accepted?
Yeah, you can click next to take control of your slide. All right. Okay. Let me start your presentation.
A very warm afternoon to the respected judges and to everyone present today. We are representing University Science Malaysia Engineering Campus code SG20A015. The group members are Divya Paramasivam, myself Satish Kumar Manogaran, and Logania Subramaniam. We are currently in our third year of Bachelor of Chemical Engineering. Our group advisor is Ayah Dr. ING Nur Ashrina Abdul Hamid. Today we would like to pitch further about our project titled EBIN, A Way to Battle Climate Change. The problem statement of our project is the plastic waste that have been increasing drastically in our environment. You may ask us why this happens. If we think logically, plastic has many advantages in terms of its usage. Some of those advantages that make plastic to be used most by us is first, it is light in weight, second, it is cheap, and third, it is long-lasting. Please note the word long-lasting. Plastic also considered as a main contributor to climate change. This is because plastic is naturally very hard to decompose. Sunlight and heat cause the plastic to release such powerful greenhouse gases such as ethylene and methane. The increasing concentration of these gases in this atmosphere leads to an alarming feedback, which is climate change. If you observe the graphs in this slide carefully, it is known that plastic production has been increasing rapidly from the year 1950 to year 2015 and tops the chart in the year 2015. By that year, plastic has literally outgrown most man-made materials in this environment. It is also clear, on the other hand, that the plastic waste are either discarded into the environment just like that, which eventually ends up in rivers and oceans, or incinerated where toxic and greenhouse gases are released to the atmosphere. The rate of these plastic waste that are being recycled is very less, in fact, which is almost 20%. This generally explains our purpose to begin this project in the first place. While in this chart, it is so clear that Asia holds the first place in discharging plastic waste into rivers and oceans, which is something not to be proud of even a little. And you're probably wondering what disposing plastic waste into oceans and rivers could do. When the microplastics present in the ocean and rivers are unwittingly ingested by the plankton populations, it may threaten them. This causes more carbon to re-enter the waters and atmosphere, leaving a greater impact behind. The aims of our project are to battle climate change, to combat this ever-increasing dumping of plastic waste, to ease the work of collecting and recycling plastic waste, and finally to convert the plastics into biofuel that we use in our daily lives. Now, I would like to pass it to the next presenter.
Thank you, Satish. And I would like to continue my discussion with project activities. And there is two project activity. One is EBIN and another one is cold plasma pyrolysis. And now I'm going to explain about EBIN. Next slide. The function of the EBIN is to reduce plastic waste and to avoid climate change. The material that we will like to use to make the EBIN is compost wood, and it will be coated with black color so that maximum amount of light energy can be absorbed by the EBIN. The dimension of the EBIN is 120 by 100 by 150 centimeter. The components that involve in the EBIN are solar panel system, infrared sensor, proximity sensor, weight sensor, and lastly piston. The solar panel system is used to absorb light energy and convert it into electric current, while infrared sensor will detect the amount of incoming plastic and send information to the microcontrollers. Proximity sensor will be placed at the bottom of the EBIN so that it can vacuum plastic near to it. Weight sensors will be placed at all the 4 chambers to calculate the total percentage of plastic present in the EBIN. Lastly, piston involved in the EBIN so that it can compress the plastic in the chamber to increase the space inside it. Next slide. Basically, this is our design of our EBIN, and it consists of touchscreen. This touchscreen will help humans to choose which type of plastic that they're going to put inside the EBIN, whether it is high-density polyethylene, low-density polyethylene, or polypropylene. This EBIN consists of totally 4 chambers. The first chamber is HDPE, followed by LDPE. Third chamber is PP, and the last chamber is specially for vacuum. The length of the EBIN is 120 centimeter, followed by width 100 centimeter, and the height is 150 centimeter. Next slide. Basically, this is the cross-section view of our EBIN from the front view. Next slide. This is the process flow of our project. First of all, human must choose which type of plastic that they're going to put inside the EBIN, and then the plastic will be sent to the chamber according to the type of plastic. EBIN will sanitize automatically after an individual passed from the place to prevent the spreading of coronavirus. When the plastic reaches the maximum capacity in the EBIN, the assigned management will be known through phone, as the EBIN is programmed and connected through an app, and that particular app is owned by Pyrolysis Center crews. Then the Pyrolysis Center crews will reach the EBIN and collect the plastic from the EBIN. And the plastics will be sent to the Pyrolysis Center, and lastly, it will be converted into fuel. That's all from me, and I would like to pass it to Logania.
Thank you, Divya. So first of all, pyrolysis is a process of thermal decomposition of organic materials at high temperature with limited amount of oxygen. So adding cold plasma into this process will break down the chemical bonds to initiate and excite reactions, allowing for the extraction of these materials before they are burnt. Cold plasma will also decrease the reaction time. Next. So as we see the alterations on the design, first of all, stainless steel is used for outside wall of combustion chamber. This is so that the chamber lasts long. And then asbestos for inside wall and glass wool for the middle wall. This is to maintain the even heat transfer. And then vertical cylinders are used so that the handling will be easy and it is affordable. And various adjustment options and controlled operation are available. Then, pressure monitoring device is installed to control the pressure in the reactor, as well as thermocouple is also installed to always monitor the temperature of the reaction, as temperature plays a major role in this reaction. Zeolite Active Plus is used for product purification, ion filter to trap the evaporated oil, nitrogen gas is used to clean the reactor before starting. Lastly, calcium carbonate as adsorbent is used for better production of oil yield and to shorten the reaction time. Next. For better and specific reaction, first of all, the properties of pyrolysis oil can be improved by hydrogenation. Then, preheat the reactor before starting. catalytic reaction where we use silica alumina as the most common catalyst is used to produce gaseous fuels, whereas thermal reaction is used to produce liquid fuels. Lastly, we can also add used lubricant oil to produce diesel-like fuel. Next. As we see the process flow of the pyrolysis process, first of all, waste plastics from the plastic snapper will enter the pyrolysis reactor where catalyst will be added according to its reaction, and then the product will go to the condenser to produce fuel gas and mixed oil. The mixed oil will then go to fractionating tower to produce gasoline and diesel. Next. I would like to pass to Satish to continue.
Thank you, Lognia, for the brief explanation about pyrolysis process. Now let's look at the outcome from this project, which is converting waste plastics into hydrogen, methane, and ethylene, as well as oils. Both hydrogen and methane can be used as clean oils. The impact from this project are it reduces plastic waste in our sanitary landfill, it enhances recycling in society, it improves the knowledge of society regarding plastics, it produces eco-friendly environment, it reduces overflowing bins and unpleasant odors, it produces cleaner streets and walkways, and produces more fuels. This project can be scaled up by creating more and more e-bins, as the design of this e-bin is already available in simple and easy form to understand. Consequently, more amount of biofuels and oils can be produced with this number of e-bins available. Our presentation ends here. Thank you for listening.
All right, thank you, Team SG20A015 for your presentation. And now I shall invite Mr. Chua to direct your question for the Q&A session.
Yeah, thank you for the team for the good presentation. I'm a little bit confused why I should use e-bin. Similar for the question in the chat box for Fahad as well. I'm not clear why I should select e-bin compared to the conventional so-called collection bins that we have, and you know the utilization and the awareness is very, very low, and how we should overcome those.
Team SG20A015, are you clear with the question?
Hello.
Excuse me?
Hello.
Yes, did you hear the question from Mr. Chua?
The voice is not was cracking. Can I?
A question from Mr. Chua is that why would can you convince us why would we option for e-bin when the function of e-bin is sort of same as the conventional recycling method, and how do you increase the awareness of people to recycle plastics basically? Yes.
Okay, thank you for the question, Mr. Chua. So, since the awareness of the climate change is already there, so we are just here providing a solution for the problem, which is to battle climate change. So our job here is to present a method for them to battle this climate change, since the awareness is already in our present times about climate change. This method just helps the people to contribute their part in battling the climate change. Thank you.
I'm totally agree with what you have mentioned, but it's still questions about the cost to make this kind of system, and also it will not improve the awareness of the people to put the so-called or to segregate the content to the right column or storage bin. Okay, so I'm looking into the practicality, and I agree that this is solution. The design is very well done, but it might have a problem on the practical aspects. Yeah. Thank you.
Thank you.
All right, and we have another. We have Dr. Stephen to ask your question, or the second question.
Yeah, basically it's also about the practicability of this e-bin, like what Mr. Leong have asked. Like what happens is, let's say, publics that throw other kind of waste into this e-bin apart from those plastic waste. Will that e-bin be able to handle this kind of waste?
Hello, sir. This e-bin will totally reject materials other than plastic because the e-bin will be programmed on what type of material that going to be in the e-bin actually. So if humans try to put some other material, it will automatically reject it. Thank you.
So how are you going to detect whether it's plastic or not? Is there a detection system in this e-bin?
Yeah, it has a detection system followed by the e-bin also having a mini camera, and the mini camera will be programmed with all kind of plastic pictures. So if humans try to put some other materials, then the e-bin will recognize it and will reject it on the spot.
Okay, but with all this kind of detection system, then the cost of the e-bin might be very high. Have you guys considered about the cost of it?
Yes, we consider about the cost around 50 ringgit plus, but we can gain back the money because we are selling the raw materials to the pyrolysis center industry, so we can gain back the money from that.
Okay, thank you.
Thank you.
All right, and we have another question from Madam Norida. She's asking, what type of maintenance will your e-bin require? Do you mind to clarify on this question?
Can I speak?
Yes.
Okay. As for the maintenance, we actually assigned a team to maintain this e-bin. So once the e-bin is full, there is an app that it will be connected to the pyrolysis center, and they will come and collect all the plastics as well as maintain the e-bin. If there's any destruction or anything happen, they will correct it. That's all. Thank you.
All right. Thank you so much, Group SG20A015, for your presentation, and thank you, judges, for the questions. And I think we should welcome the next team, which is team SG20A042 from Universiti Teknologi Malaysia to pitch their project. Please welcome. Team SG20A042. Are you there?
Hello. Can you hear me?
Yes, of course, I can hear you. Yes.
Yeah, okay.
All right. You may start your presentation whenever you're ready.
All right. Good afternoon to the organizer, judges, and all the participants. We are from SG20A024 from Universiti of Teknologi Malaysia. I'm Teo Jing.
I'm Amir.
I'm QAD.
Our topic would be on the reduction of carbon dioxide using algolite. And from our topic, you might have an idea that our proposed invention is somehow related to light. But how can carbon dioxide reduction be related or be linked to lights? So before my member Amir will reveal the operation, we will leave it for you to guess.
The Southeast Asia is particularly exposed to the impact of the climate change. And according to the Asian Development Bank, the Southeast Asia recorded the fastest growth for the carbon dioxide emission in the world is between 1990 and 2010. Here shows the carbon dioxide emission from each country. And the data show that although these countries cover less than 1% of the Earth's surface, have consumed 75% of the world's energy and caused the 75% of the global greenhouse gas emission. However, the climate change is not only urgent in Southeast Asia, but a worldwide issue. And from 1990 to 2015, next slide. Thank you.
The total warming effect from the greenhouse gases to the Earth's atmosphere increased by 37%, as we can see from the chart previous slide. The carbon dioxide is primary greenhouse gas and accounting for about 76% to 81% of total greenhouse gas emission. And the carbon capture and storage, which is the process of capturing the carbon dioxide and depositing it to prevent the emission to the atmosphere, is an attempt to limit the effects of the global climate change. Next slide. As we can see from this chart, the carbon dioxide emission in Malaysia is mainly contributed by the electricity and heat generation. And do you guys know that the street lighting is actually the one of the biggest electrical energy consumer, which accounting for up to 40% of the total energy consumption in standard city worldwide. And the lighting accounts for nearly 5% of global carbon dioxide emissions. Malaysia government is spending about 80 million ringgit annually on the power bills and nationwide village street light maintenance. However, the street lighting is an essential public service and cannot be separated from our life. Therefore, the electricity cost and the environmental factor have inspired our teams for this innovation. Another issue in Southeast Asia regarding the climate change is the harmful algae bloom. The warmer water due to the climate change might favor the harmful algae growth and increase the algae bloom occurrence in the Southeast Asia. And in this case, Philippines and Malaysia are two of the most affected countries. And this is an unhealthy cycle in which the climate change causes the warm water to boost the algae growth, and this develop to a thicker blooms that absorb more heat and cause the water warmer that enhance the blooms. Therefore, we are cultivating the microalgae as a part of our project, which can reduce the algae blooms besides combat the climate change. And the biomass produced can be collected and used as the aqua feed and animal feed. Besides reducing the algae blooms and climate change, we are using the microalgae because of its promising future as a renewable energy, the potential application in biopharmaceutical and nutraceutical industry, as well as the wastewater treatment. And as a brief for our project, we are using the carbon dioxide, the solar energy, and wastewater for the algae cultivation, implemented with the street lighting as well. And our objective is to achieve the climate protection and the wastewater treatment at the same time.
So to counter all the problems, an innovative street light as the substitution of the usual street light has been proposed, and we name it as algae light. As our main concern is reducing carbon dioxide concentration in the ambient air, the microalgae are able to convert the carbon dioxide into useful biomass and oxygen. The efficiency of microalgae in capturing carbon has proven to be 400 times more effective than trees taking the same footprint. Next. What makes this algae light as the promising future is because of the dual mode system. The dual mode system is not only cover one aspect, but it covers three remarkable aspects. The first one is the hybrid system of microalgae and solar-powered street light. This means that it acts as a carbon dioxide converter and illuminates the surrounding area without the utilization of electricity. Next, this innovation can function both day and night. Microalgae utilize sunlight to convert carbon dioxide into biomass and oxygen, making the conventional reactor not operate at night. With the integration of LED that is brighter and more energy efficient, microalgae are able to convert the carbon dioxide in the air by utilizing the bright artificial light even at night. And the last aspect is the algae light able to treat wastewater or oxidation ponds that are rich in nitrogen and phosphorus. The treated water can be released back to the river. Next. There are three main aspects in conducting this project. The first one is the integration of solar panel and battery storage to the algae light. The second one is designing and development of algae photobioreactor, also optimizing the growth of the microalgae. And the last one is the production of bio-based product from microalgae biomass, such as for animal feed. So in order to realize this algae light, we have tested the required aspect in a small or laboratory scale. The results have proven that the microalgae are able to reduce the concentration of carbon dioxide, even supplemented with LED as the source of light. Moreover, this algae light is not just a random idea. Under the supervision of our advisor, our senior has developed artificial tree using the same concept and won IBCX in 2019. However, our generation does not stop here. We take this idea even further through algae light. Artificial tree aim at reducing carbon dioxide indoor, but with algae light, it can be applied both indoor and outdoor. This can be achieved with algae light because of higher capacity on absorbing carbon dioxide, zero electricity usage, and remote system that allow the reactor to function all day long. This is the process of cultivation of microalgae that will be used for our algalite. Besides, the efficiency of using solar panel on pumping and aeration has been tested on a smaller scale. The result is amazing and ready to be applied on a larger scale, which is algalite. We have tested on cultivating the microalgae using water from the oxidation pond located near our faculty. Based on our study, microalgae are able to treat the water by reducing the organic content in it. The water then is safe to be released into the river. This is truly impressive as it extends the capability to save our planet by not only reducing the carbon dioxide in the air, but also treating the contaminated water surrounding us. We really hope that this innovation will be as successful as artificial tree. This may help us in reducing carbon dioxide both indoor and outdoors.
So for a quick recap, as well as been mentioned by my team members, the significance or the values brought by our proposed invention is that the currently available main culprit for global warming, which is carbon dioxide, is reduced through utilization by these microalgae, and it further prevents the production of more carbon dioxide when it's used as substitution for normal street light in the generation of energy. So why should we choose algolite? We know very well that deforestation and the dependence on fossil fuels can only be cut down but not eliminated, because let's be practical, the development of the country and also the accommodation of to increase the for the increasing population definitely requires some unavoidable sacrifices. And since these sacrifices cannot be avoided, our invention does its best by providing a balance in it by mitigating the negative impacts brought by these developments. So speaking of the financial concerns of our project, just as similar to any other invention, the development stages are always the costliest, but trust me, the invention is truly worthwhile in the long run. So in future, this invention might also be used for electric generation in rural areas as power supply to the underprivileged members of the society. And only inventions that benefits all levels of society can be regarded as good invention. Thank you.
All right, thank you, team SG20 A042 for your presentation, and I shall take question from Dr. Stephen for the Q&A session. Dr. Stephen, your question, please.
Okay, good afternoon, and thanks again for the very innovative project and also good presentations. So my question, first, of course, may I know what type of microalgae you guys will be using for this algolite? Is there a specific strain? Hello, can you guys hear me?
Team SG20A042.
Yes.
Yes, we are using the chlorella species for the microalgae.
Okay, so my next question will be about the feasibility of using this algae light as a street light, right? Like we all know, the microalgae requires nutrient also to grow. So over time, the nutrient in the medium of the algolite might depleted. So how actually you guys are going to replenish this nutrient to the algae? Or how are you going to replace the medium inside the algae in that algolite?
Good morning, good afternoon, doctor. Thank you for your question. In fact, our invention actually requires maintenance for at least a month to because as you said, the algae might not be as active as in the initial stage. We need to actually change or inoculate new microalgae. At the same time, we need to do water changing, as the water might be muddy as for a long time. Yeah, so we need maintenance by inoculating new fresh microalgae or changing water at the same time.
Okay, yep, the maintenance might be a problem, because if you have too many of these algolites in the street, then it'd be not feasible to actually maintain it for everyone. every now and then, right? So maybe you guys need to think out something to improve this maintenance. Okay, that's all from my side. Thank you.
All right, thank you, Dr. Stephen, for your question. And we have another question from Madam Nurida in the chat box. She is asking, what is the cost to assembly one AlgoLite prototype? Can you roughly tell us how much does it cost to assemble the prototype?
Thank you for your question. The cost to assemble one AlgoLite prototype is up to thousands. Okay, but just as I mentioned in my previous slide, just as similar to any other invention, the development stage definitely requires a very huge amount of invention. But we just because we are using this thing, so we can save costs on other maintenance. On maintenance, we use on usual street light, and also we using LED light, so it has a longer lifespan as compared to the conventional light, and also it illuminates wider area, which means that the algo light don't have to place very near to each other. They can be placed far from each other because the area it illuminate is wider. So the initial stage is costly, but is a good investment if we see in the long run. So we cannot see the return in a short time, but yeah, we have to leave it for a long time, so we can only see the return.
All right, understood. All right, thank you, Team SG20A042 for your presentation, and thank you, judges, for the questions. And perhaps we can have Madam Nurida back with us asking questions. Probably you can unmute your mic and ask your questions. Yeah, sometimes I'm afraid I would not be seeing your question in the chat box, but perhaps after the lunch break you could join us and unmute your mic to ask questions to the presenters. Right, thank you so much for the presentation. And now we shall enter a lunch break, and I shall see you at 1:35 p.m. to start with the lecture. And meanwhile, let us share with you a video introducing American Chemical Society as well as the Fundamental and Applied Sciences Department of Universiti Teknologi PETRONAS. Please enjoy, and I shall see you soon at 1:35 p.m. Malaysia time. All right, thank you.
Applied chemistry is in our everyday lives. We see chemistry in almost everything. For example, the air we breathe, the food we eat, and even the fuel that powers up our cars. Chemistry is important because we see it in our everyday lives, and everything we observe is due to chemical reactions. My best UTP experience, I developed a catalyst to convert carbon dioxide into methane. And aside from my FYP project, I also managed to lead student organizations such as the Society of Petroleum Engineers student chapter, where I was elected the Deputy Vice President.
I did my 7 months of internship at Japan. The experience is really amazing and really great. I'm doing the research is regarding about the deep UTP solvents using as a catalyst or as a co-solvents as well to enhancing the biodiesel production.
Chemistry is an important part in any future industry. Thanks to UTP's strong industrial linkages, as well as the wide range of expertise, I can apply what I've learned in the industry.
Backed by its strong ties with PETRONAS, the parent company of UTP, the graduates from this program is able to tap onto that opportunity and enter into the oil and gas industry in Malaysia. The content of the program allows some level of versatility for the graduates to explore beyond the oil and gas industry in Malaysia. So it pushes the boundary to explore all other job options available in the country and also regionally and also internationally. So that makes UTP graduates high-value graduates.
As you know, in our applied chemistry course, for the first 3 years, the student will be doing fundamental chemistry. They also will be doing some computational chemistry. So after the 3 years, they will do a specialization package where they can do research projects. So in this research project, they can do either in environmental, they can do in catalysis, they can come up with new materials that can reduce pollution. After they have done this research, we believe this will equip them to go into the job market. In Malaysia, a lot of companies are looking into chemistry who has knowledge in this area. So we believe in UTP, we will prepare the students for this job market that is not only today, but will be useful in future.
UTP Applied Chemistry Program received prestigious accreditation from the Royal Society of Chemistry, or RSC, positioning the program to be internationally recognized. This provides assurance to employer and students in a competitive global job market. The RSC recognition also gives opportunity to students and academic staff. The Mobility in Exchange program among the RSC accredited institutions worldwide. The Applied Chemistry program in UTP also offered 3 specializations, namely petrochemistry, sustainable chemistry, and nanotechnology, to cater for the Industrial 4.0.
The youth is important in Malaysia, and it's very important for us to ensure that they can participate in Malaysian well-being. So besides securing a job, we want to also get the students involved in the nation's issues, especially in environment, in pollution, in coming up with alternative energy. In UTP, we believe our course is preparing the students for these areas. When the students make a discovery in the lab, especially in the final year research project, we ourselves as a lecturer for past 21 years, we feel the honor to see the light in their eyes when they find a discovery. So, and many times these students have made useful discovery, which we are using it for our research project in later years. Coming to UTP is a good step for our youth to take up especially the applied chemistry course which we are offering here. Join us. Together we can dream up new possibilities.
Building a rocket is totally not in our syllabus, but as a physics student, we do love to apply knowledge that we have learned from the class to the real world, such as momentum, thrust, acceleration, and so on. Is it a difficult subject? Yes, but is it worth it? Absolutely. Best thing is we do get 100% support from our lecturer in all our discussion.
UTP is one of the leading private universities in Malaysia. In fact, it is able to also to compete with the more established public universities in Malaysia. It is recognized the world over. It is reflected by its achievements and awards that it has accumulated over the years. And the university also boasts a collection of lecturers and facilities to reflect the quality that it claims to possess, to attract good and quality students from the world over. In addition to that, it's also it's the only university in Malaysia that is able to offer undergraduate courses in nanotechnology, renewable energy, and oil and gas exploration. And the syllabus and the course content was cleverly crafted to prepare students for the real world. And that opens up a plethora of job opportunities in Malaysia and, of course, in the global markets.
Here at Fundamental and Applied Sciences Department, we are bringing a totally new learning experience. This experience comes in various multi-mode learning activities, which are multidisciplinary, interactive, practical, and also relevant to the current trend of the industries. These include adjunct lectures, where the leading experts from industries will be giving lectures to the students. They will undergo a 7-month of internship at various agencies or industries, either locally or internationally. To name a few, there are students have been sent to Japan, Germany, and Australia, for that matter. Some of the students are also being brought to places like Baram oil field in Sarawak, where they will be able to see the exploration of oil and gas. There also will be industrial visits to places like Tun Hussein On National Hospital, where the student will be witnessing or will be experiencing or will be looking at the latest technology, laser technology, to treat diseases. Our reputation speaks for itself, where we have an accomplished alumni group who has won various awards nationally in the past. Let's begin our journey. Join us. Together we can dream of new possibilities.
Applied chemistry is in our everyday lives. We see chemistry in almost everything. For example, the air we breathe, the food we eat, and even the fuel that powers up our cars. Chemistry is important because we see it in our everyday lives, and everything we observe is due to chemical reactions. My best UTP experience, I developed a catalyst to convert carbon dioxide into methane. And aside from my FYP project, I also managed to lead student organizations such as the Society of Petroleum Engineers student chapter, where I was elected the deputy vice president.
I did my 7 months of internship at Japan. The experience is really amazing and really great. I'm doing the research is regarding about the deep utility solvents using as a catalyst or as a core solvents as well to enhancing the biodiesel production.
Chemistry is an important part in any future industry. Thanks to UTP's strong industrial linkages, as well as the wide range of expertise, I can apply what I've learned in the industry.
Backed by its strong ties with PETRONAS, the parent company of UTP, the graduates from this program is able to tap onto that opportunity and enter into the oil and gas industry in Malaysia. The content of the program allows some level of versatility for the graduates to explore beyond the oil and gas industry in Malaysia. So it pushes the boundary to explore all other job options available in the country and also regionally and so internationally. So that makes the UTP graduates high-value graduates.
As you know, in our applied chemistry course, for the first 3 years, the student will be doing fundamental chemistry. They also will be doing some computational chemistry. So after the 3 years, they will do a specialization package where they can do research projects. So in this research project, they can do either in environmental, they can do in catalysis, they can come up with new materials that can reduce pollution. After they have done this research, we believe this will equip them to go into the job market. In Malaysia, a lot of companies are looking into chemistry who has knowledge in this area. So we believe in UTP, we will prepare the students for this job market that is not only today, but will be useful in future.
UTP Applied Chemistry Program received prestigious accreditation from the Royal Society of Chemistry, or RSC, positioning the program to be internationally recognized. This provides assurance to employer and students in a competitive global job market. The RSC recognition also gives opportunity to students and academic staff. The Mobility in Exchange program among the RSC accredited institutions worldwide. The Applied Chemistry program in UTP also offered 3 specializations, namely petrochemistry, sustainable chemistry, and nanotechnology, to cater for the Industrial 4.0.
The youth is important in Malaysia, and it's very important for us to ensure that they can participate in Malaysian well-being. So besides securing a job, we want to also get the students involved in the nation's issues, especially in environment, in pollution, in coming up with alternative energy. In UTP, we believe our course is preparing the students for these areas. When the students make a discovery in the lab, especially in their final year research project, we ourselves, as a lecturer for past 21 years, we feel the honor to see the light in their eyes when they find a discovery. And many times these students have made useful discovery which we are using it for our research project in later years. Coming to UTP is a good step for our youth to take up especially the applied chemistry course which we are offering here. Join us. Together we can dream up new possibilities.
Building rocket is totally not in our syllabus, but as a physics student, we do love to apply knowledge that we have learned from the class to the real world, such as momentum, thrust, acceleration, and so on. Is it a difficult subject? Yes, but is it worth it? Absolutely. Best thing is we do get 100% support from our lecturer in all our discussion.
UTP is one of the leading private universities in Malaysia. In fact, it is able also to compete with the more established public universities in Malaysia. It is recognized the world over. It is reflected by its achievements and awards that it has accumulated over the years. And the university also boasts a collection of lecturers and facilities to reflect the quality that it claims to possess, to attract good and quality students from the world over. In addition to that, it's also it's the only university in Malaysia that is able to offer undergraduate courses in nanotechnology, renewable energy, and oil and gas exploration. And the syllabus and the course content was cleverly crafted to prepare students for the real world. And that opens up a plethora of job opportunities in Malaysia and, of course, in the global markets.
Here at Fundamental and Applied Sciences Department, we are bringing a totally new learning experience. This experience comes in various multimodal learning activities, which are multidisciplinary, interactive, practical, and also relevant to the current trend of the industries. These include adjunct lectures, where the leading experts from industries will be giving lectures to the students. They will undergo a 7-month of internship at various agencies or industries, either locally or internationally. To name a few, students have been sent to Japan, Germany, and Australia, for that matter. Some of the students are also being brought to places like Baram oil field in Sarawak, where they will be able to see the exploration of oil and gas. There also will be industrial visits to places like Tun Hussein On National Hospital, where the student will be witnessing or will be experiencing or will be looking at the latest technology, laser technology, to treat diseases. Our reputation speaks for itself, where we have an accomplished alumni group who has won various awards nationally in the past. Let's begin our journey. Join us. Together we can dream of new possibilities.
Applied chemistry is in our everyday lives. We see chemistry in almost everything. For example, the air we breathe, the food we eat, and even the fuel that powers up our cars. Chemistry is important because we see it in our everyday lives, and everything we observe is due to chemical reactions. My best UTP experience, I developed a catalyst to convert carbon dioxide into methane. And aside from my FYP project, I also managed to lead student organizations such as the Society of Petroleum Engineers student chapter, where I was elected the deputy vice president.
I did my 7 months of internship at Japan. The experience is really amazing and really great. I'm doing the research is regarding about the deep utility solvents using as a catalyst or as a co-solvents as well to enhancing the biodiesel production.
Chemistry is an important part in any future industry. Thanks to UTP's strong industrial linkages, as well as the wide range of expertise, I can apply what I've learned in the industry.
Backed by its strong ties with PETRONAS, the parent company of UTP, the graduates from this program is able to tap onto that opportunity and enter into the oil and gas industry in Malaysia. The content of the program allows some level of versatility for the graduates to explore beyond the oil and gas industry in Malaysia. So it pushes the boundary to explore all other job options available in the country and also regionally and so internationally. So that makes UTP graduates high-value graduates.
As you know, in our applied chemistry course, for the first 3 years, the student will be doing fundamental chemistry. They also will be doing some computational chemistry. So after the 3 years, they will do a specialization package where they can do research projects. So in this research project, they can do either in environmental, they can do in catalysis, they can come up with new materials that can reduce pollution. After they have done this research, we believe this will equip them to go into the job market. In Malaysia, a lot of companies are looking into chemistry who has knowledge in this area. So we believe in UTP, we will prepare the students for this job market that is not only today, but will be useful in future.
UTP Applied Chemistry program received prestigious accreditation from the Royal Society of Chemistry, or RSC, positioning the program to be internationally recognized. This provides assurance to employer and students in a competitive global job market. The RSC recognition also gives opportunity to students and academic staff. The Mobility in Exchange program among the RSC accredited institutions worldwide. The Applied Chemistry program in UTP also offered 3 specializations, namely petrochemistry, sustainable chemistry, and nanotechnology, to cater for the Industrial 4.0.
The youth is important in Malaysia, and it's very important for us to ensure that they can participate in Malaysian well-being. So besides securing a job, we want to also get the students involved in the nation's issues, especially in environment, in pollution, in coming up with alternative energy. In UTP, we believe our course is preparing the students for these areas. When the students make a discovery in the lab, especially in their final year research project, we ourselves as a lecturer for past 21 years, we feel the honor to see the light in their eyes when they find a discovery. So, and many times these students have made useful discovery, which we are using it for our research project in later years. Coming to UTP is a good step for our youth to take up especially the applied chemistry course which we are offering here. Join us. Together we can dream up new possibilities.
Building rocket is totally not in our syllabus, but as a physics student, we do love to apply knowledge that we have learned from the class to the real world, such as momentum, thrust, acceleration, and so on. Is it a difficult subject? Yes, but is it worth it? Absolutely. Best thing is we do get 100% support from our lecturer in all our discussion.
UTP is one of the leading private universities in Malaysia. In fact, it is able to also to compete with the more established public universities in Malaysia. It is recognized the world over. It is reflected by its achievements and awards that it has accumulated over the years. And the university also boasts a collection of lecturers and facilities to reflect the quality that it claims to possess, to attract good and quality students from the world over. In addition to that, it's also it's the only university in Malaysia that is able to offer undergraduate courses in nanotechnology, renewable energy, and oil and gas exploration. And the syllabus and the course content was cleverly crafted to prepare students for the real world. And that opens up a plethora of job opportunities in Malaysia and, of course, in the global markets.
Here at Fundamental and Applied Sciences Department, we are bringing a totally new learning experience. This experience comes in various multimodal learning activities, which are multidisciplinary, interactive, practical, and also relevant to the current trend of the industries. These include adjunct lectures, where the leading experts from industries will be giving lectures to the students. They will undergo a 7-month of internship at various agencies or industries, either locally or internationally. To name a few, there are students have been sent to Japan, Germany, and Australia, for that matter. Some of the students are also being brought to places like Baram oil field in Sarawak, where they will be able to see the exploration of oil and gas. There also will be industrial visits to places like Tun Hussein On National Hospital, where the student will be witnessing or will be experiencing or will be looking at the latest technology, laser technology, to treat diseases. Our reputation speaks for itself, where we
Applied chemistry.
All right, welcome back to SEA-GIC 2020. Hope you all enjoyed the short break Next, we shall move on to one of our key highlights for SEA-GIC 2020. Let me welcome our first renowned keynote speaker, Dr. Muhammad Firoz Khan from Universiti Malaya, Malaysia, to share his knowledge and experience on the potential sources of air pollution and mitigation strategies in Malaysia. Please welcome. Dr. Firoz Khan, are you there? All right, please welcome. Dr. Firoz Khan, are you there? Yes. I can see that you have unmuted your mic. Is there any problem from that side? From your side? Dr. Firoz, can you request control one more time? Um, um, all right, while we think, Dr. Firoz Khan's title for today's lecture would be about potential sources of air pollution and mitigation strategies in Malaysia. I hope from his presentation we would we would learn a lot about the future prospect or future what Malaysia would do in terms of combating climate change itself. Right, Dr. Firoz Khan, can you unmute your mic right now? Because organization. Doctor, can you try to request control one more time so that we know that you are here? Mm-hmm. Mm-hmm. Dr. Firoz Khan, I can see that your mic has unmuted, but I cannot hear any from your side. Um,
some other way.
Oh yes, yes. Now I can hear you. Yes.
Can you hear me?
Yeah, now I can hear you.
Okay, is it okay,
Yeah.
okay to proceed now from the
Yes,
beginning?
yes. I think I should start again to
Yeah,
introduce
please.
you. All right.
Yeah,
Okay.
please.
All right. Let
So,
me
yeah.
welcome our first renowned keynote speaker, Dr. Mahathir Han from Universiti Malaya, Malaysia, to share his knowledge and experience on the potential sources of air pollution and mitigation strategies in Malaysia. Please welcome, Doctor.
Okay, let me start from the beginning.
Okay.
I want to go to the first slide. Or can you control slide from your end?
You may request control. You may click request control.
Is already the control with me, but slide is not moving.
I see. You can try to click next to go to the next slide. Yes. Can you try to click next on your keyboard?
No, it's not moving.
It's not moving. That's okay. I think we can do it for you to move the slide, and you just let us know. Okay.
All right. Okay. Can you?
Doctor, is it okay?
Can you go to the first slide?
All right. Okay.
Okay.
This is the first slide.
Okay.
Right? Okay.
Yeah.
Okay. All right.
Thank you, everyone. Welcome to my presentation, and it was having interruption. I hope you will able to see the leftover slide that I have. I want to quickly brief you about the presentation that I have prepared for you. This is about a problem. The problem since morning you have been presenting here. This is somewhat different from your presentation. This is about air pollution in Malaysia, and I will also talk about mitigation, how we can mitigate air pollution, that I will discuss briefly with you. Can you go to next slide, please? From this slide, I want to discuss about air pollution. When we talk about air pollution, it always comes to my mind that how good it is or how bad it is. It is because air pollution, it is a mixture of air particle, tiny air particle, and also a mixture of atmospheric gases. Some of the gases is very toxic. And from this slide, let's talk about the fundamental about air pollution. You can see some of the sources here I listed, I inserted at the bottom. These are the sources that always emit pollutant or atmospheric composition. And those atmospheric composition, as you can see on the top, I grouped them to, one group is, we classified them as a primary pollutant. And then on the right side, I have another group, and that group is listed as a secondary pollutant. And this pollutant, the primary pollutant, it always coming, the source I listed here, inserted here at the bottom. These are the source, not all about this source. On top of this source, there are numerous sources we have keep contributing atmospheric composition and atmospheric pollutant. Right, and on right side, the group of the composition I listed here, this group of composition in the atmosphere that throw a number of heterogeneous reaction, atmospheric reaction that is spontaneously occurring in the atmosphere, and then those are the mechanism. This secondary pollutant is always coming in the atmosphere. Right, can you proceed to the next slide? And if we talk about air pollution, this air pollution, not only we are having, we observe in Malaysia or in Southeast Asia, air pollution, this is a global issue. You can see from the picture here on the left side, Beijing in China, New Delhi in India, they always having like episode of air pollution in a particular time in a year. Everybody we know in New Delhi, they always observe winter fog. This winter fog is very deadly in New Delhi, particularly for the elderly people, because during this time, air pollution level is very high. And this air pollution level, as you see at the bottom in Indonesia, this is due to the biomass burning or forest fire. And this air pollution issue, not only we are having in Southeast Asia or in Asian cities, it is even observing in the continental cities. For example, London, Paris, California, and also in Sydney. Right? Do you know how many people died every year only because of the air pollution? For the current context, as you know, COVID-19, the pandemic that is already around the world, everybody we are having, right, experiencing very deadly situation. Do you know how many people so far due to the COVID-19, how many people has been died? It is about 1.4 million, right? And then if we talk about air pollution, every year 7 million people died due to air pollution. It is about 5 times more compared to the current pandemic that we are observing. So this is how air pollution is having impact on our daily life throughout the world. So let's proceed to the next slide. Would you proceed next? And now let's talk about in Southeast Asia, what we are having in Southeast Asia due to air pollution. In Southeast Asia, as you know, we are having forest fire. And this forest fire always having in Indonesia, Malaysia, and Borneo side. And then once we have forest fire, the forest fire causes haze. Our visibility goes very down. From the picture itself, you can see visibility around the entire Southeast Asia is very low. This is because of the atmospheric pollution from this forest fire that causes the low visibility. And then that causes that impact on our daily life. In many countries like Malaysia, Indonesia, Thailand, local government, they need to shut down our school, college, and our business center, right? It has effect on our daily life. Can we proceed to the next slide, please? I want to talk a bit more about Southeast Asian biomass burning or transboundary pollution. And do you know the reason behind this biomass burning or forest fire? This is simply from the slide you can see, this is simply because of slash and burn. The slash and burn, it is a very common practice, very easy, cost-effective practice that our farmers who are doing farming, they make use, right? Once they have the farming waste, they simply burn. right? And that causes the Southeast Asian forest fire and eventually causes the biomass-related forest fire-related haze. If we go to the next slide, you will see that once we have that fire at the surface level, the fire simply doesn't be in the surface. The fire goes to the soil, very deep into the soil. And the reason behind is in Southeast Asia, many parts we have here, our soil is kind of peat soil, right? Peat land. And then once the fire goes to the peat land, it started burning for days, even weeks, even months, right? And then this fire, not simply a fire. If we see in our next, can you click another click? You can see there is this. Can you click next, please? Yes. You can see once we have peat land, peat soil burning, this is a simple combustion reaction. And this combustion reaction is as simple as your chemistry student, mostly here, you know. But problem with this combustion reaction is if we have biomass burning or a peat soil burning, on top of this energy production, carbon dioxide emission, there are huge amount of toxic pollutant also emit. That is our great concern as a chemist, as an air pollution, like who we are working on air pollution. Can you go to the next slide? I want to show you here a number of combustion related process, forest fire, peat, soil and coal burning, all is combustion, right? And from this combustion, you can see at the bottom, I listed a number of pollutant here. From left side, you can see particle pollution in the form of black carbon, organic carbon, brown carbon, right? Primary organic carbon, secondary organic carbon. Secondary organic carbon, it is a like subject here in a topics in Southeast Asia. We really need to more focus on that because that causes many other secondary pollutant to generate in the atmosphere. One example is ozone, right? In Southeast Asia, this is one of the great concern, ozone pollution at surface level. And if we see a number of inorganic gases and organic toxic molecule even, once we have this kind of forest fire, pit soil burning, we always have emission of this pollutant. Can you proceed next slide? In the next slide here, I want to briefly explain about the insight, some of the composition. Due to the time constraint, I cannot explain more. I will go very quickly. Black carbon and brown carbon, as you know, it has impact, number one, on our human health, and it also impact on our climate because it is a climate forcer. Black carbon, it causes global warming. Brown carbon, it causes global, more like cooling effect, cloud albedo effect. Can you go next slide, please? In the next slide, we have the photochemical smoke. Do you know about photochemical smoke? This is kind of oxidant in the atmosphere. It generates through like heterogeneous photochemical reaction. And this oxidant, do you know how that generate? That generate if we have sunlight, oxide of nitrogen, volatile organic compound, these oxidant always generate. For example, ozone, other photochemical oxidant. Once we have photochemical oxidant in our ambient air, our sky become more like brownish in color. And that always we often experience, we often see in the Beijing and in Sydney, California. Can you go next slide, please? And then here I want to talk about particulate matter, air particle, very tiny particle. And that tiny particle, how small this tiny particle, how small is small, that you can see from the slide here, the picture here left side, if we compare with our human hair. Right, and then this tiny particle simply pass through our respiratory system and causes a number of respiratory related disease, and it also causes in our cardiovascular related disease. And recent studies has already established that this air particle can also pass through our bloodstream and come into our brain and can causes a number of brain related neurological disease. One of the commonly symptom that we often, elderly people, they experience dementia, memory, they simply lose memory. And this dementia or Alzheimer kind of disease, it is often due to the exposure of this tiny particle. Can you go next slide, please? Here I want to show you the effect of air pollution in Southeast Asia. Do you know how many people died in Southeast Asia only due to the biomass burning in 2015? 100,000 people died. I have given a list of reference here. If you are more interested, I would ask you to go over this reference, and you can come to know more about those effects in Southeast Asia. Can you go next slide, please? Here, I want to introduce you a new thing about mitigation of air pollution and how we can do mitigation. We can make use approach here. This is called chemometrics approach, and chemometrics, I believe, is somewhat new, could be for you, but this method is quite helpful to identify the hotspot of air pollution. Can we go next slide, please? In the slide here, the chemometrics, what is chemometrics? You are already familiar now, right? It is an algorithm modeling. And how does it work? At the beginning, we need to have measurement and chemical analysis in our lab. And during our measurement chemical analysis that we often do in our project, right? And that always give us a set of data. Right, that set of data we can make use in this chemometrics model, and this chemometrics model will help us to identify the hotspot for the pollutant. Can you go next slide here? I have given here a number of receptor model, chemometrics model. I have given link. If you are more interested, you can go over the link and you will come to know more about this model. You can make use in your work. Next slide, please. In the next slide here, two slides, one by one. One is PMF, one of the best and appropriate model, robust model. It is because this model, if we make use in chemometrics to identify the potential source of the pollutant, our calculation will have less uncertainty, less error. So this is widely accepted for current context. And in the next slide, I have another model. Can you go next slide? In the next slide here, this is one of the simplest model, PCA-MLR. And this model, you can simply make use even with your very limited data. The problem associated with this PCA-MLR model, this model will have high uncertainty. Right? Error will be very high. In that case, there is another approach called absolute principal component score. So this approach is somewhat like advanced and will have less uncertainty. We often use absolute principal component score for our chemometrics modeling. Can I go next slide? I have given here like some of our result during strong haze, and next slide I have moderate haze. And in these two slides, you will see during a strong haze time in Malaysia, the potential source that we can see biomass burning, right? Secondary organic aerosol, those are the potential source during haze episode. And we also have a number of studies. We made comparison during haze time, data from Cheras, Kuala Lumpur, Muar, and also data from satellite data from Sumatra. We made a number of comparison and we have visualization here. You can see pattern of the pollution. It is somewhat similar, no matter the height, the like level of the pollution, but pattern is similar. So it's simply saying that pollutant, once we have biomass burning, forest fire in Sumatra, it is impacting even in Malaysia. Can we go next slide? During the moderate haze in Malaysia, we also identified the number of pollution source here, and we made a number of validation by using some other model, cross validation, and we identified coal-fired power plant, biomass burning, and transportation are the potential source in Malaysia. And then if we go next slide here, can we go next slide? In the next two slide, I just have briefly want to introduce you the air pollution trend in Malaysia. In the next slide, can you go? We have been using here, I mean, carbon monoxide and PM10. Carbon monoxide and PM10, if we see the about 20 years trend here, for the very top bottom, on the right bottom slide, you can see for the Malaysia, overall Malaysian CO trend, you can see CO trend is steadily increasing, right? Can you go next slide? And then if we compare with the PM10 trend over last about 20 years, you will see at the very bottom the overall data for Malaysia from about 48 stations that we have here. We summarized data and we found that PM10, it has been decreasing in the early 2000. However, the yearly trend is it started increasing steadily in the last few years. Can we go next slide? So the summary here is Indonesian biomass burning or Malaysian biomass burning from our local scale biomass burning, and also Malaysian Borneo biomass burning. This is the event that every year causes haze in Malaysia. And what are the approaches that can make use to mitigate? Descriptor modeling or chemometric modeling could be one of the best model. Cheaper and cost effective and much simpler, and some of the result here I already discussed, and in my understanding that oil plant management of the land use transportation in Malaysia, Borneo and Malaysian Peninsula can assist Malaysia to be more environmentally sustainable. Can I go next slide? Here I quickly want to, next slide please, quickly want to announce here that we are having a micro-credential course. The course name is Chemometrics in Air Pollution. This course online soon under The website will be Future Learn. So everybody here, you are welcome to join our micro-credential course. This course will give you briefing and introduction about air pollution and how we can mitigate air pollution. So thank you everyone. Even though the time I had interruption, I hope this insight about the problem, air pollution problem in Malaysia, the insight about this problem and the chemometric approach that will help you to have your better understanding. Thank you everyone. Thank you so much.
All right. Thank you so much, Dr. Feroz Khan, for your speech. I would like to conclude a bit from what you said. So basically, air pollution in Malaysia is not only mainly from the gases emission from the industry, but mainly from the farming as well. That happens occasionally, and these two incidents definitely have bad impacts toward our health, especially the respiratory systems and the inhaling of the particles itself. And we actually have a question asked in the chat box. Is from Leong. He's asking, what do you think about the job perspective that chemist graduate can look into when it comes to air mitigation as part of environmental chemistry industry? So what's your opinion about that, Doctor?
It's a very good question, since these topics, this subject is quite new in environmental science, particularly in Asian context. Atmospheric science, air pollution issue and mitigation strategy that we have been working with. This is somewhat new issue, but I can see there are a lot of scope to work on. Many things we can work out. Southeast Asia particularly, this is a hot spot for some of the atmospheric pollutant, not only pollutant, some of the composition cause that is responsible for air pollution or health impact. Some of the composition in Southeast Asia, that's the hot spot, can causes emission of greenhouse gases. So I can see there are a lot of scope can be worked out. Because eventually that is impacting on our health, right? Once something you will work out can help to mitigate our health issue, local issue, the zonal issue. So there are obviously there are a scope, there are career opportunity around. I hope we really need many people to come out from Southeast Asia. So that's simply I can say one example. I can just tell you here. I have been talking about say Southeast Asia biomass burning, right? This is a tropical area, right? Tropical rainforest area, and rainforest, it is a hot spot for some of the organic compound emission. For example, like isoprene, terpene, it is coming from Southeast Asian rainforest, right? So this isoprene, terpene, it is not simply organic compound, right? They have a lot of impact on atmospheric chemistry, and eventually that impact on our local scale air pollution. So once it will impact on our air pollution, it will impact on our health, right?
Very true, very true.
So we need people who are from medical science, who are from engineering background, who are from mathematical background, programming background. There are a lot of people can work out and can have opportunity in. I mean, if you are interested to work. If you are interested to work on air pollution, so no matter you are a chemistry background, like if you are the programming background, there are a lot of scope like in atmospheric science, air pollution, a lot of scope for programming. So in my sense, I would say, particularly for Southeast Asia, you have a scope. I would say that you just try to grab.
Understood. Yes, all right, doctor. There's another question, and how do we decide on developing the most suitable models for the air monitoring? Do you have any comment about that?
Yeah, I mean, it is as simple as we can see. Since we are working on this model, we know still there are a scope that, for example, in Southeast Asia, there are a number of satellite data source in Southeast Asia. As you know that if we want to do measurement in our lab or analysis in our lab, in Southeast Asia, we simply cannot have a lot of budget to buy instrument, right? So in that sense, see if somebody here who are interested to work on modeling, right? So they can develop model. So data we have in the satellite source, so they can simulate the data and make use the data for our public, for our government, for our general people, right? So there are a scope that modeling people they can I mean they have a scope that they can do work on modeling in air pollution.
All right, doctor, last question.
Yes.
Just now you mentioned about chemometric modeling. So can we actually use chemometric modeling in air pollution to help in coming up with a warming indication on the haze occurrence?
Right. I mean, chemometrics, no matter which like topics you are working with, chemometric, this is a very generalized term, and chemometrics you can make use once you have data, right? If you work in the lab, always we have a set of data, right, at the end. So that data we need to work out, right, to simplify our data for presentable or for our thesis writing, for our publication, right? So these are the chemometrics model can help us. So no matter it is in air pollution, or no matter it is in environmental other pollution, or no matter it is a set of data like could be climate related data or any data, you can make use chemometric on your own way. So I'm working on air pollution. Yes, chemometrics helps me a lot to work out my data. Is that okay with you?
Yes, yes, Doctor. All right. Thank you so much, Dr. Muhammad Firzhan, for spending time with us to share with us about your research, and thank you so much for your informative sharing session from you.
So thank you, everyone. Thank you so much. It was an interruption. So thank you, everyone. It is very good to share with you all. So I wish our next presentation session will carry on smoothly. Thank you, everyone.
All right. Thank you. All right. So if the participants, if you have any questions, you want to contact Dr. Firzhan, you may contact him on his email. You can contact him through Gmail or through his email. Basti. All right. Thank you, Doctor. All right. So let's proceed to the third pitching session for today, and let's welcome Team SG20A050 from University of North Sumatra to deliver about their project. Please welcome. Team SG20A050 from University of North Sumatra. You can try to request control. All right. And you may unmute your mic and start your presentation.
Yes. Can you hear me, sis?
Hi, Team SG20A050. Can you try to move your slide? You can just click next once you have request control. Yeah, you can use your keyboard as well to move the slide. Hello, Miss Lina. Can you try to move your slide?
I have tried, but cannot sis.
Hello, Team SG20A050. Yes, all right.
Okay.
You may start your presentation. All right.
Environment is no one's property to destroy. It's everyone's responsibility to protect. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, our honorable judges and the finalists of SEA-GIC 2020. Today, ladies and gentlemen, we are going to present our project. As we know that human activities are related to electrical energy. The demand for electrical energy in Indonesia continues to grow in line with economic growth and population, and thus uses coal as fuel for very large power plants. At least 27% of the world's total energy output and more than 89% of all electricity is generated from coal due to its overwhelming in quantity, easy and inexpensive extraction process, and low-cost infrastructure requirements. Coal can increase the emission of carbon dioxide particles which have a negative impact on the environment called global warming. And this is in line with climate change, which encompasses not only rising average temperatures, but also extreme weather events, shifting wildlife population and habitats, rising seas, and a range of other impacts.
Ladies and gentlemen, Based on Union of Concerned Scientists, Indonesia is one of the 20 carbon dioxide emitting countries in 2018. It is at the rank 9th with the number of emission 0.65 metric gigaton and 10th of per capita emission with 2.30 metric ton. In 2018, total coal consumption in power plant last year reached 18.3 million tons, or 86% of total domestic coal consumption. Ladies and gentlemen, Indonesia is known as a maritime country with an area of 3.22 million kilometers of ocean. So the judges see a river wave energy as an alternative energy generated to the effect of air pressure movement due to fluctuation in wave movement. Ladies and gentlemen, we are Winners Team. I am Lina Sadisregar and my partner is Yasara Ulfa and Hafida Oktaviani from University of North Sumatra, Indonesia. Have an idea to solve problem with the title Wave Planner, Water Wave Plan Modifier based on piezoelectric in supporting the renewable energy.
Wave planner is the right wave planner is the right technology to solve global warming due to the use of coal to generate electricity by utilizing wave of water. Wave planner is an innovation in electrical energy based on piezoelectric, and it utilizes renewable energy in the form of water waves as the main source of its energy. Next, wave planner. In principle, the wave of the river water will hit the buoy at the bottom of the tube. If the buoy moves, it will move the iron handle which is connected to the buoy. Wave planner utilizes river wave with the help of piezo materials. Piezoelectric is a material that can generate an electric field when applied pressure vibration. Next, the judges wave planner will work out if the water wave hits the floor. This movement can cause magnetic friction. Next, the result at the knobs of connected piezo lying under the magnet on the wooden part. The judges movement from piezo sent to the piezoelectric energy conversion medium, so that it will produce energy in the form of direct electric current or AC. And then the electric current must change into alternating current or DC using rectifier circuit. And finally, it is the stream through a cable connected to the lamp. Ladies and gentlemen, based on the result of the experiment, the electric voltage generated by the wave planner is 12 volts with power 3002.5 watts. Thus, the voltage generated is able to make the lamp turn on.
Sorry. So, ladies and gentlemen, what's the advantages from wave planner? The first, the tools used in technology use materials that are cheap and sustainable. And the second, optimization of river water wave, which are natural potential. And the third, environmentally friendly, so it doesn't cause noise pollution, emission, or air pollution. And the last, wave planner is portable technology. Next. And benefit from wave planner. The first is reducing CO emissions that have an impact on the environment. And the second, increase public knowledge related to natural potential such as river, waves, and electricity generator. And the third, information materials and formulation in providing electric energy from natural potential in order to minimize the import burden.
The next slide is implementation and future prospects. The first step we are going to do this technology is technology making. In making this technology, we collaborate with the professionals. The second, we are going to testing the technology. After that, we are establish collaboration with PTPLN and cooperation with regional hubs. By cooperating with PTPLN and the government will make it easier for us to socialize to the community. The next step, we are going to socialization with the community. In socializing the community, we will be helped by communities or organizations, activities, environment. After that, we are going to implementing this technology to our daily life. The last step is evaluation and monitoring to make an update later. Ladies and gentlemen, as you can see here, this is our project display titled SolidWorks software. So, based on our explanation, we get the conclusion that post-plenum technology is an appropriate technology in providing electrical energy by utilizing rudder waves. The resulting voltage is 12 volts PV with a power of 302.5 watts. Post-plenum technology is also a renewable energy is an alternative solution to overcome global warming in 13 years. That is our explanation about our project. Thank you for your attention. Don't forget to love our environment and save our planet. Wassalamualaikum warahmatullahi wabarakatuh.
All right, thank you, Group ST20A050 for your presentation. And now we shall proceed to the Q&A session, and I shall invite Madam Nurida for her to direct her question. Please welcome.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon. Thank you for the presentations. I believe that Indonesia is actually surrounded by oceans, and I believe that is the idea that you get actually to use the wave around the country to generate energy. Okay, just wanted to ask the question on what is the movement pattern or power height of the wave that you think would impact the energy production? Is it going to impact, or it does not give any impact to the energy production?
Thank you the judges for your question. I will answer the question that the movement from the waves have an impact.
It will not impact. Okay.
Yes.
Have you actually conducted any lab testing to test whether your ideas actually works?
Thank you for the judges. The next question will be answered by my friend. For the research about, our team has not done it since the wave-planning idea is still within the plan and technologies are getting organized. To get a direct research stage, we need some time for testing so the goal can be achieved. Then for the research results that is presented, we have a reference which suggests that 1 bit can deliver 12 volts.
Okay, thank you very much for the answer.
Thank you so much for your question.
All right, now I shall invite Dr. Stephen for him to direct his second question for this Q&A session. Dr. Stephen?
Okay, good afternoon everyone, and Salam Sejahtera. So here I just need some clarification because of course we all know that wave energy is better to be utilized at the ocean, but from your slide I noticed that you guys focusing more on the river wave. So is the river wave going to provide significant energies compared to oceans? Can you clarify that?
Thank you, the judges, for your question. My friends will going to answer the question.
Thank you for your question, and I want to answer to your question. And we are use water wave because the bigger the water wave, the greater the pressure that will receive on the piezoelectric, so that the voltage produced will be greater as well.
Yes, that's why I want to ask, because usually reverse wave does not have such a high energy compared to ocean wave, right? So from your side, I saw you guys using river wave a lot. So have you guys checked on whether the river wave can provide a higher power compared to ocean wave or sea wave?
For that, we are not comparing it yet, but we have some reference about it. And based on our reference, we get the conclusion that the river wave still have an energy to make a power lamp. So the bigger the water wave, the greater the pressure that will be received on the piezoelectric, so that the voltage produce will be greater as well. And also in our society, river is more the quantity of river is more than the sea.
Okay, because usually river doesn't really create a lot or generate a lot of waves. So I think the best location for this to implement is basically at the oceans, right? Okay, so thanks for your answer. Thank you.
All right, thank you, judges, for the questions, and thank you, Team SG20A050, for your presentation. And I think we should welcome the next team, Team SG20A008 from Universiti Kebangsaan Malaysia, to start pitching on their project. Please welcome.
Thank you. I just want to do a mic testing.
Yes, I can hear you. Yes.
Okay. Shasha, can you hear me?
Yes. Can you hear me?
Okay. So I'm requesting the control.
Okay, request control. Can the previous group release control? The previous group A050. Right. All right.
All right.
Okay, you may start your presentation.
All right. Carbon dioxide. Who would have thought that this colorless, odorless, and relative non-toxic gas would be a threat to humanity in the 21st century? According to the Intergovernmental Panel on Climate Change report, IPCC, at the current rate of CO2 emission, temperature could increase by 2 degrees Celsius that would be detrimental to our Mother Nature. Ever since, most innovation had always focused on solving the issue by reducing CO2 emission, but never using it. What if I tell you if we could use CO2 to build your houses? Assalamu alaikum and a very good afternoon, I bid to the honorable judges and enthusiastic audience. We from Universiti Kebangsaan Malaysia are pleased to present you on our title, capturing CO2 gas using activated carbon with a theme of utilization of CO2 emission in concrete.
So, how far do we know about cement? Apart of being the second most consumed product in the world, it accounts for 8% of global greenhouse emission every year. Southeast Asia itself contributes to 1.25% of CO2 emission every year. This is equivalent to 871,200 square feet of trees absorbing CO2 every year. Calcination is the process that emits CO2 gas in cement kiln. Heating up limestone thermally decomposes it, and both the process emits a lot of CO2. With that being said, we had clearly identified our problem statement where to minimize the negative impact of climate change by utilizing 1,395 megatons of CO2 emission in Southeast Asia countries by 2030. This makes our problem statement significant, relevant, and measurable. We proved this by showing in graph 1.1 and 1.2 where Southeast Asia is subjected to 1,395 megatons of CO2 emission by 2030. Change is only possible if we align our problem statement based on Sustainable Development Goals. Why SDG goals? Because our objective aligns with 4 SDG goals, which is SDG 3, 8, 12, and 13. Our objective is to solve one target out of each SDG goals, which makes our project more relevant and significant to SEA countries. Our objectives are to chemically manufacture green products that utilize CO2 gas to create a carbon-neutral environment by 2030 and to prioritize energy-efficient process in manufacturing green products that prevents worsening of climate change by 2030. It might be in Canada, European Union, South Korea, and US, but is there such technology in Southeast Asia? The technology is CCU. CCU stands for Carbon Capture Utilization Technology, where it prevents CO2 emission to the atmosphere by utilizing it. It is a cutting-edge technology that battles for climate change to reduce greenhouse gases. CCU technology has 3 steps: capture, conversion, and utilization. In our case, our project Carbon Resub can capture CO2 gas from cement kiln in factories, which is convert CO2 minerals and utilize it as building materials. Agricultural waste has always been a problem where disposal results in air pollution and landfills. But now we can utilize this waste to synthesize activated carbon. The best part of Carbon Resub is where we synthesize AC from agricultural waste tailored to the highest agricultural waste such as EFB, rice husk, and coconut shells in SEA countries. The data here shows that agricultural waste where EFB is the highest in Malaysia and Indonesia, where rice husk is the highest for most of the SEA countries. Interestingly, the Philippines has the highest amount of agricultural waste in rice husk and coconut shells. Now, let's talk about synthesizing AC through pyrolysis techniques from agricultural waste. This technique has 3 stages where the first stage is carbonization, activation, and the final stage, which is leaching out the ash content. In the first stage of process, biomass is partially burned at constant temperature ranging from 450 to 700 degrees Celsius, approximately to 1 to 2 hours to be converted into biochar. In second stage of process, biochar is then heated in tube furnace with nitrogen gas, which is then adjusted to CO2 gas. Biochar sample takes 1 hour of activation process and it is cooled down under room temperature with presence of nitrogen gas. In final stage process, the sample is refluxed with a potassium carbonate solution and the mixture is filtered and dried. Activated carbon is so promising and superior due to these qualities that we made it as our focal point in our project.
Project Carbon Resub comprised of 4 important stages in order to produce the end product. Synthesis of carbon result starts from absorption, where CO2 gas is released in cement kiln, which is captured and absorbed on the surface of AC through its porous structure. It is worth to mention that the absorption rate is higher through the application of coating on the surface of AC. A specific coating that is made of N-functional group amine is coated on the surface of the AC to absorb CO2 onto the surface. A chemical bonding called dipole-dipole moment is formed between the positively charged N atom and negatively charged C atom. Next, the desorption would allow the absorbed CO2 molecules to be released from the activated carbon mat. The CO2 gas is then channeled into the refrigerator, where it undergoes liquefying process to chemically convert CO2 gas into liquid. Finally, it is redirected into a concrete mixing chamber to be mixed, mineralized, and produce a higher compressive strength concrete. Are you wondering what happens after CO2 liquid mixed with the concrete? Here, we explain about the chemical reaction of carbon result concrete. It has two main stages to be converted to a solid concrete. Firstly, it undergoes early carbonation, where it produces nanoparticles of calcium carbonate. These nanoparticles are 10 to 80 nanometers in size, which acts as a nucleation site for initial hydration of the cement. The initial hydration state is where we obtain hydrated calcium silicate, which is the mineral found in the concrete. Note that calcium hydroxide acts as a buffer solution to maintain the high pH alkalinity, which minimizes the possibilities of corrosion in reinforced steel. Also, these nanoparticles result in 30% of higher compressive strength than commercial concrete, according to Green Building Index, Malaysia. These graphs proves as evidence that explains how CO2 mixed concrete are stronger and aligns with the standardized strength requirement in construction. Thus, our project outcome brings significant change, and we classified it into three major parts. Our green product helps to reduce 1.4 gigatons of CO2 by 2030, manages 1.14 kg of municipal solid waste generated every day, and saves 554 million liters of water that is used in concrete industry every day. Not only that, it is also energy efficient, where microwave has 87% of efficiency, which is the most eco-friendly. More importantly, carbon result can bring big impact to an industry of 1.88 trillion in market size, and Southeast Asia can further leverage on $400 billion of CO2 utilization industry in concrete. Project Carbon Result also gives you another layer of how this would impact Southeast Asia. Firstly, implementation of policies like incentive-based regulation would encourage more construction companies to build green buildings. This is proved by the future greenhouse scenario graph on the top right, where with current policies, the greenhouse emission would be around 50 to 60 gigatons compared to no policies, which is above 80 gigatons. Our project also boosts the Southeast Asia economy by providing new market and job opportunities as well as GDP growth annually. This can be clearly seen in the graph in the bottom right, where as CO2 emission decreases, the GDP growth increases. From an environment perspective, this project would ensure cleaner air for all, which significantly improves their health. CCU technology would also be adapted quickly in sea countries through this project. Most importantly, carbon result provides a carbon-neutral environment where no CO2 would be left escape into the atmosphere without finding its true value. With that, carbon result envisioned to provide a cleaner, healthier, better environment for all. Thank you.
All right, thank you, Team SG20A008, and we shall proceed to the Q&A session. We have Dr. Steven to ask the question for the Q&A session.
Okay, good afternoon, everyone. So again, a very good presentations by the students. Okay, so my first question will be like, okay, activated carbon we all know is actually already quite commercialized. So just want to make sure what is so special about your activated carbon compared to the existing one? Can you elaborate on this?
Yeah, may I elaborate, Shasha?
Yes.
Okay, so why is our activated carbon is so special is that we are actually synthesizing it from the waste, agriculture waste, which kills two birds with one stone, because it also solves the agriculture waste problems, and also it is synthesized with zero cost material, because activated carbon, even though it's very efficient, but it is expensive commercially. So we are providing a much cheaper option with a two-way solution where we can deal with two different problems at one time.
Okay, thanks for explanations. But from what I can see from this carbon recycle program, so basically, have you guys taken into account the cost of the process? Because what I see, the energy requirement actually is quite high. Like when you want to synthesize the activated carbon, the pyrolysis process requires huge energy consumptions. Then you use the microwave energies, right, to dissolve the CO2. Yeah, that one also requires quite a lot of energies. So have you guys taken that into consideration?
Yes, I would say that one thing that we need to understand is that we are targeting it for Southeast Asia, which is in a very big scale. So when we are using a lot of energy, we are trying to minimize, we are trying to find solution to minimize at every point where we are using microwave instead of vacuum or chemical cleaner, which is less eco-friendly and more energy consumption. And also, we are trying to, pyrolysis is where that's a different kind of process compared to carbon recycle, because carbon recycle is a type of process. But for pyrolysis, yes, we would try to find out a better way in terms of like generating activated carbon through this waste.
Okay, thanks for your question. Thank you.
Understood. And then we go to the second question for the Q&A session. We have Mr. Chua. Your question, please.
Yeah, in actual fact, the question was answered because I'm looking into the energy cost involved, even though the material is claimed to be the so-called raw material is claimed to be zero cost, but I do not recall that this project will have lower cost than the rest of the so-called technology that we have today. I don't know.
Yeah, Mr. Chua, basically this is an initial, or I would say a new kind of technology where we are implementing CCU. Basically, the green concrete had been quite a big thing in countries like Europe, and also like people's like Melinda Gates Foundation are actually funding 10 million and 20 million for this kind of projects. So I think when it comes to the energy efficient, I think it is. We try to make in each process, we try to make the energy as efficient as possible. And that's the reason why we are targeting it to a bigger scale. Instead of just being, implementing in just one country, we are targeting big, we are targeting in Southeast Asia.
I agree that the simulation, when you go to the mass scale, will have a better in cost. But again, a simulation is a fundamental for us to commercialize or to scale up this whole innovation or design. So I think we believe that you should take this into consideration when performing the simulation. Right? Thank you.
All right. Thank you.
All right, and we actually have another question from Madam Nurida. Madam Nurida, your question, please.
Okay, just a question for me. Why did you actually choose to absorb the CO2 onto solid material when it has been proven that the efficiency of CO2 absorption into liquid phase would be more efficient and would require less energy for the CO2 release back again?
Okay, so basically we had one thing in mind, solving a lot of problems in one go for this project. So we saw there was waste management that's been a huge thing that's been unsolved for Southeast Asian countries. So we plan to implement that, and activated carbon being the very efficient substance, we felt that absorbing CO2 would be more relevant, because we need to dissolve it back. Because if it's absorbing through a liquid phase, the desorption phase might be complicated or sophisticated compared to this coating that we dissolve it through microwaves. Yep.
Okay, thank you for the answer.
Yep. Thank you.
All right, thank you, judges, for the question. Thank you, Team SG20A008, for your presentation. And let us welcome next team, Team SG20A019 from Universitas Islam Indonesia, to start pitching their project. You may request control and start your presentation whenever you are ready.
waiting for approval. Okay. Thank you.
All right. Can you move the slide? You have to request control and click next on your keyboard. Yes, sorry.
Okay.
Hey, Shahrul, why are you coughing?
Can you see? There is full for smoke in here.
Do something happen there?
Yes, I think in here there's forest fires.
Oh my god, it's very hot today.
Oh my god, are you haven't taken a bath, maybe?
No. I have taken a bath in this morning.
So why?
I don't know, but I think the weather is different than before.
Oh, I see, guys. You like this must be because of the sharp increase of carbon dioxide at this time. Global warming, dirty air, and melting of the ice on both poles of the Earth is caused by the greenhouse effect, which is the result of carbon dioxide production. Okay, guys, I will to tell you about improved carbon dioxide utilization efficiency using seawater by electrochemistry process in closed reactor system. Guys, can you see the picture here? Look, these pictures are different from each other, right? The first picture is in the city in 2009, but the second picture here is the condition of the city at this time. Clearly, we have a big issue with air pollution which contains lots of carbon dioxide. What will happen if we ignore this problem? Guys, do you know? Over the last century, the burning of fossil fuels like coal and oil has increased the concentration atmospheric carbon dioxide. This happens because the coal or oil burning process combines carbon with oxygen in the air make carbon dioxide. Clearing of land for agriculture, industry, transportation, and other human activities has increased concentration of carbon dioxide. In its fifth assessment report from National Oceanic and Atmospheric Administration, a group of 1,030 independent scientific experts from countries all world cite the industrial activities have raised atmospheric carbon dioxide levels from 190 ppm in 1950 and the level of carbon dioxide increased to 420 ppm in 2020. Carbon dioxide is too high can cause reflex solar thermal radiation, causing an increase in the temperature at the Earth's surface or global warming. Carbon dioxide can cause serious health problems. For example, is acidosis and other respiratory disease. Carbon dioxide needs to be processed into something useful. There are many technologies that are being developed so that effect of climate change remains below 2 degrees Celsius. Water makes up about 71% of the Earth's surface, while the other 29% consists of continents and islands, consists of 96.5% seawater and 3.5% is freshwater. The major components of seawater contribute to the physical chemical properties of the ocean. Since the major components of seawater are constant throughout the ocean or the market principle, it is possible to treat seawater as an electrolyte solution. Our supervisor is Mr. Wiyogo Priyo Wicaksono with our team are Syahrul, Tiara, and Mehdi from Islamic University of Indonesia. We have an innovation to build an electrochemical reactor system for the conversion of carbon dioxide to produce hydrogen gas by utilizing seawater as the low-cost electrolyte. Syahrul, do you cook anymore?
Yes, I have drink water. I feel so good right now.
Can you help me to explain the mechanism?
Okay, I will tell them about the mechanism. Okay, guys, I will tell you about component of system and mechanism of system. The reactor system, just like a fuel cell, consists of platinum metal as cathode, separator half-plus membrane selective, graphite as anode, DC power supply, hose, and hydrogen storage. hose for carrying carbon dioxide and hydrogen gas to an electrochemical reactor system, DC power for operating system, and hydrogen storage for the stored hydrogen gas. And the reactor is closed reactor system. Okay, this is a video for mechanism of system. Carbon dioxide float in electrolyte solution, in this case water, then will dissolve and produce carbonic acid. Carbonic acid will dissolve ion carbonic acid and ion hydrogen gas. In the other hand, in anode, occurs oxidation reaction from water and produce oxygen gas and hydrogen plus. Ion hydrogen plus will go to the cathode through Harkless membrane selective and occurs reduction reaction and produce hydrogen gas. Catalysts are contained in water and are connected by a lead wire to cathode. The system is better than photoremediatory or chemical treatment. The system can be applied to remove carbon dioxide by inducing polymetric chemical reaction. The system has the advantage of not regenerating carbon dioxide during the process. The system could serve as a novel carbon dioxide utilization technology and high-value added hydrogen gas fuel production device for decreasing climate change. The product in the system is hydrogen gas, and hydrogen gas can be hydrogen fuel for fuel cell vehicle in the future.
Very good explanation, Shahrul. Okay, can you tell them about the advantage of the method?
Hey, Diana, the team is not only you and me. There is Mediana. Mediana, please explain to them about goals and advantages.
Okay. Please be calm, Shahrul. So I will tell them about the goals from this innovation. So the goals from this innovation are: first, optimizing carbon dioxide utilization. The second one, reduce carbon dioxide emission for extreme climate change. And the third one, to create innovative technology for hydrogen gas production as clean fuel. And also, the advantage is environmental fuel friendly. So after we use clean energy, it will not generating carbon dioxide. The second, low cost. It's because the main material is seawater. In the earth consists 68% seawater, so we can get it easily. And the third is user friendly. It causes because our innovation tools is used and simple. And the last is easy to get feedstock, so we can get feedstock it easily. For example, is seawater. And our innovation have an impact and prospect future. The first, reduce carbon dioxide in the atmosphere so the climate change and global warming can be controlled. Second one, provide low cost and innovative technology for industry to managing gas industrial activity waste. And the third, provide hydrogen gas as clean fuel energy. So the conclusion is carbon dioxide can be transformed through electrochemically through electrolysis process, then detrimental extreme climate change into renewable, valuable, and inexhaustible hydrogen gas production as a green fuel. So this is the illustrate the carbon dioxide electrochemical reactor that compact, portable, low energy, and user-friendly, so readily for industrial scale up. And also, the innovation achieved a conversion carbon dioxide to hydrogen gas fuel with high efficiency. So we can battling the climate change by converting carbon dioxide into hydrogen gas through electrochemical. That's all from our presentation. Thank you for your attention. SEA-GIC 2020.
All right, thank you, team SG20 A019 for your presentation, and now we shall proceed to the Q&A session. We have Dr. Steven to please direct your question. Yes.
Okay, so good afternoon, and again, a very good presentations from the students. So my questions will be, so you're going to use seawater inside the electrolyte systems. How long do you actually need to replace the seawater inside that electrolyte system? Because eventually the CO2 inside will be running out, right? For generating the ions.
Okay. Thank you for your question. I will try to answer the question. Seawater needs to be treated because blocks will occur due to turbidity or water turbidity caused by biological biological contaminants, macromolecular compounds, insoluble inorganic compounds, and suspend particle or colloids, aluminium, iron, and silica oxides. Treatment for seawater to reduce the turbidity of seawater that have been used include information, coagulation, flocculation, filtration with adjustment to the membrane. And in the seawater, there are sodium chloride, which is a sodium chloride is a strong electrolyte. So because seawater can be electrolyte solution.
Okay, but usually how often you need to actually refill the seawater inside that electrolyte system?
I will answer the question. Maybe for time seawater for electrolyte system is 1 hour.
1 hour. So every 1 hour you need to change the seawater inside the electrolyte system?
Yes.
Yes.
Okay, and my next question will be what do you do with the seawater that you're taking out? Because from what I see, the byproducts of the electrolyte system, there will be higher concentration of carbonic acid inside that seawater. So how do you treat that seawater after the electrolyte process?
Okay, I will to answer the question. The seawater will be desalination to remove all dissolved salts and produce essentially distilled water. This distilled water can then be subjected to the electrolysis, alkaline electrolyte, and electrolysis cells. So because in seawater have many impurities, so that we reacted in the reactor, it is feared that a lot of salt will be formed. Thank you.
Okay, thanks for the answer. Thank you.
All right, thank you, Dr. Steven. Maybe we can have another question, probably from Madam Nurida or Mr. Chua. Another question for team SG20A019. All right, Madam Nurida, you may direct your question.
Okay, thank you. What would you think would be the cost to actually make one of your closed reactor system?
Okay, thank you the question. I will try to answer the question. The cost of the reactor system is 170 ringgit because in cathode we use platinum. We use platinum nanoparticle mainly, where the platinum will be applied or plated to the metal, so that it can reduce the price to be cheaper. And deposit platina nanoparticle based carbon graphite. Platina is mean nanoparticle.
Would you think using platinum is very expensive rather than considering another type of metals to be used as the electrode?
Sorry?
As we know, platinum is very expensive. Okay. Would you consider to use another type of metal to replace platinum as the electrode materials?
We use platinum and nanoparticles and the cathode is graphite to plating using nanoparticle of platinum.
So you're actually coating the platinum onto the graphite electrodes?
Yes.
Okay.
Yes.
All right, thank you.
All right, thank you, team SG20A09 for your presentation, and thank you, judges, for your questions. And now we shall resume to the next team, which is team SG20A033 from Swinburne University of Technology Sarawak campus to pitch their project. Please welcome. All right. You can start your presentation whenever you are ready.
Hi, I'm still not able to control the slide. I already request for the control.
Only one person in the team could do the request control.
Yeah, I will be the one.
All right. Then can you try to request control one more time?
Okay.
All right.
Okay.
Okay. All right.
Let me try.
All right.
Okay.
All right. You're good to go.
Hold on. Okay.
Team SG20A033, you may start your presentation.
Rewind back. Good afternoon to the distinguished panel judges, key speakers, and fellow participants. Today, we're privileged to present our project, CO2 utilization in bicarbonate lime mortar with industrial waste, for the 2020 Southeast Asia Global Innovation Challenge under the CO2 utilization area. We are chemical engineering students from Swinburne University of Technology Sarawak campus. First, let me introduce myself. My name is Nur Ali Alisa Azirin, and I will be presenting the problem statement, project aim, and also the project impact. My two other group mates are Emily Tan, where she will be presenting the project activities, and Sylvester Chai, where he will present the project outcome and the ability to scale up. Among the largest anthropogenic sources of CO2 include energy-related CO2 emission at 33 gigatons of CO2 emission in 2019 and cement production, which produces 4.1 gigaton of CO2 in 2018. These two industries combined also produce tremendous industrial solid waste such as cement kiln dust and also fly ash, which amounts to approximately 3.1 billion tons in 2019. The over-emission of CO2 is an inevitable concern that has caused global warming, which leads to climate change. Additionally, even though some of these solid waste has found beneficial application, most of them still needs to be in landfill. Therefore, in this project, we aim to develop an innovative approach to utilize CO2 and the industrial solid waste to produce a construction material, namely the bicarbonate lime mortar with industrial waste, BLMIW, through mineral carbonation process. This project environmental gains include the reduction of greenhouse gas emission and industrial solid waste through beneficial reuse as raw materials in line with the zero waste and closed loop material flow concept. This aids to reduce the pressure on demand and landfill facilities or industrial storage for the solid waste. Economy impacts related to the production of BLMIW as an alternative and cost-effective construction material has the potential to generate new economy return. Furthermore, with direct CO2 utilization, the cost and energy requirement associated with CO2 desorption and storage can be saved. Lastly, the cost of solid waste disposal can be reduced. So what is the use of lime mortar? Lime mortar is used in the conservation of building built by lime mortar itself and also as an alternative to ordinary Portland cement. Conventional lime mortar is made of water, lime, and sand. The carbonation of lime mortar with atmospheric CO2 produces calcium carbonate, which binds the sand to form the lime mortar. CO2 uptake in this reaction is limited by the contact area and also the CO2 diffusion rate. With that, I will now let Emily present her presentation for the project activities.
Hi, I'm Emily. Now I'm going to talk about the project activities to solve the problems that shared by Alisa. In this project, 3 innovative approaches are taken. The first approach is replacing water with bicarbonate solution generated by an accelerated weathering of limestone process. In AWL, limestone absorbs carbon dioxide to produce bicarbonate solution. It is a low-tech strategy that is not costly. Current application discharge the bicarbonate effluent into the ocean to combat ocean acidification. Using bicarbonate solution to replace water provide not only carbon but calcium to form lime mortar. This diagram shows the absorption tower setup. It uses calcium carbonate pellet as the packing with influence of compressed air and distilled water. In our project, ambient air with a concentration of CO2 of 0.04% was used instead of flue gas CO2 concentration around 3 to 20%. The operating condition hence is for direct air capture condition at 25 degrees Celsius and 1 atm. Future work is planned to utilize post-combustion CO2 concentration and condition. This work therefore is a proof of concept of the proposed idea having the condition at extreme low. Reported AWL CO2 capture efficiency in literature is greater than 90% using the flue gas at post-combustion absorption condition. The second approach is replace lime with an alternative calcium oxide source from industrial waste. Cement clean dust, a byproduct from cement manufacturing, was used in this project because of its high CaO content at 62.8% by weight, compared to industrial metal slag which contain 20.9% of CaO by weight. Both sources produce 220 to 400 million tons annually. Calcium oxide reacts with the bicarbonate solution to carbonize metal to produce calcium carbonate that binds the sand to produce lime mortar. This ensures stable sequestration of CO2 in the construction material. Thirdly, additional industrial waste with cementitious and pozzolanic characteristics are introduced. In this project, fly ash, which is a byproduct from power generation, are used. They function to improve the strength property of lime mortar. Fly ash has been successfully used in applications such as replacement of Portland cement, which achieve comparable strength at later age. This diagram shows the metal carbonation setup. Mixture of CKD, fly ash, and sand are compressed in the mold and is placed between two plaques for the metal carbonation process. The bicarbonate solution is introduced through the various injection points. The percentage of fly ash addition used was 3 to 7%. CKD is used to replace lime to achieve 5 to 25% of CaCO3 precipitation content. Now I would like to pass the presentation to my teammate Sylvester.
Thank you, Emily. Proceeding to the project outcome, this section discusses three main results. First, the CO2 absorption and capture efficiency. The AWL process for direct air capture gave an average absorption efficiency of 31.74%. This efficiency is pale in comparison to post-combustion efficiency of more than 90 and 97% respectively. This is attributed by the higher CO2 concentration of flue gas compared to ambient air. The calcium carbonate absorption capacity obtained experimentally is 0.61 kg carbon dioxide per kg calcium carbonate, which is higher than that of literature, which is only 0.44 kg carbon dioxide per kg calcium carbonate. Also, the bicarbonate concentration achieved in direct air capture is 111.77 mg per liter, with no carbonate ion present. Next, we look at the strength of bicarbonate lime mortar with industrial waste. It is shown that typical lime mortar shows an inferior unconfined compressive strength compared to bicarbonate lime mortars. This is due to its low carbonization of calcium hydroxide with air to form calcium carbonate. Bicarbonate lime mortars exhibit higher strength because of the use of bicarbonate solution, which provide both calcium and carbon source for its precipitation. Bicarbonate lime mortar with 30% industrial waste shows a comparable strength to bicarbonate lime mortar, as both samples gave similar CaCO3 content. Next, last we present the metal carbonation efficiency. The precipitation conversion efficiency shows an excellent result of 82.09% to a maximum of 91.1%. Provision of an illiquid metal source from industrial waste allowed high conversion to its desired metal carbonate to form the binding between the sand particles. To have an idea on the potential of this project, a simple evaluation using a mid-size power plant characteristic was conducted. Based on the calculated result, up to 867 million kg of carbon dioxide can be captured annually. Also, the annual potential utilization of solid waste such as CKD and fly ash can be amounted to 1.76 billion kg and 309 million kg respectively. A plus side, up to 4.4 billion kg of bicarbonate lime mortar with industrial waste can be produced for construction purposes. Moving on, to ensure ability for project industrial scale up, 2 future studies will be undertaken, consisting of project optimization and techno-economical study. For process optimization, involve the optimization of all process key parameters that impact the AWL process, mineral carbonation process, and mortar curing by the design of experiment DOE software. The interrelation between factors will be established to derive the optimized process condition for industrial scale up. For the techno-economical study, a 4-level hierarchy approach will be implemented. It involves an in-depth analysis of the input-output structure, process flow structure, heat integration, and economic feasibility of the proposed method. This result will be benchmarked to the conventional method to determine its feasibility. This ends our presentation, and thank you for your attention.
All right, thank you, Team SG20A033 for your presentation. And now we shall proceed to the Q&A session. We have Dr. Stephen. Your question, please.
Okay, good afternoon again, students. So again, thanks for the good presentations and an interesting idea to actually capture the CO2 using the cement that you guys synthesized. I just want to clarify one point from your slide. I saw that using the normal air, right, for the capturing system, you guys show me that the efficiency is actually lower than the post-combustion air, but then the absorption capacity is higher. So can you clarify why is that happening?
The absorption efficiency is lower for direct air capture is because the CO2 concentration in ambient air is much lower. As we increase the concentration of carbon dioxide in the system, the partial pressure of the CO2 will be higher. So based on Henry's law, the solubility of CO2 will be higher in water. So if you for the absorption capacity, we actually perform a simple calculation that the mass before the CO2 absorption and after the CO2 absorption, and we use that CaCO, the calcium carbonate mass that is consumed during the process to calculate. So we actually just make a simple calculation, and it shows a higher result compared to literature.
Okay, so I think you need to verify that, because usually if you have higher efficiencies absorption process, then usually the absorption capacity will be higher, but your result shows the contrary results. So that's why I'm a bit curious that you might need to check on that. Okay.
All right. Okay, thank you for your question.
Okay, that's all from my side. Thank you.
All right, thank you.
All right, sorry for that. Thank you, Dr. Stephen, for your question. And now we shall proceed to the second question for the Q&A session. And perhaps we can have Madam Nurida to ask the second question to Team SG20A033. Please welcome.
Okay, thank you, Tim, for the presentation. Would it be possible for you to actually replace your carbonate solutions by utilizing the seawater instead?
Because the process that we are using is accelerated weathering of limestone, which then produces a bicarbonate solution. That's why we utilize the calcium carbonate instead of seawater. And it also produces the bicarbonate solution, which then we use as a water replacement to make the mortar.
Okay, thank you.
All right, thank you, Madam Nurida. Thank you, Dr. Stephen, for your questions. And thank you, Team SG20A033, for your presentation. And We shall proceed to the next team. I shall call upon team SG20A026 from Universiti Sains Malaysia to start pitching on their project. Please welcome.
Hello, can you, okay. Okay, good afternoon, judges, committees of SEA-GIC 2020, audience. We are from Universiti Sains Malaysia and presenting our project titled Next Generation Carbon Capture and Storage, Chemical Looping with Oxygen Coupling, CLOU. The world is facing the challenge of climate change. The main driver of climate change is the human emission of greenhouse gases. Of all greenhouse gases, carbon dioxide contributes to more than 81% of the total greenhouse gases. And the most important activity contributing to emission is burning of fossil fuel. The International Energy Agency assessed that the carbon dioxide emitted from coal combustion is responsible for over 0.3 out of 1 degree Celsius increase in the global average temperature. Southeast Asia overall energy demand has grown over 80% since the year 2000. This results in an increasing trend in annual carbon dioxide emission with a total of 33.13 billion tons in the year 2018. However, the dependence on fossil fuel for power generation, at least in Southeast Asia, is still rising, as it is a more secure, more affordable, and more sustainable source. Renewable energy in our region only meets around 15% of the region's energy demand. Thus, multiple technologies and approaches are made to capture, transport, and store carbon dioxide produced by these coal power generators. This is known as carbon capture storage, CCS. Okay, one of them is chemical looping combustion, CLC. This process produces energy via unmixed combustion, harnessing carbon dioxide emitted by creating a chemical loop between an air reactor and a fuel reactor. Oxygen carrier, typically metal oxides, selectively transport oxygen from an air reactor to the fuel reactor to fully oxidize the fuel. There is no actual mixing fuel and for combustion to occur. The oxygen carrier would circulate in a loop between these two reactors. CLC produced gases are ideally consist of only carbon dioxide and water and are free of diluting species, allowing subsequent water condensation, compression, and the storage of carbon dioxide. Conventionally, traditional CCS technology require gas separation unit to either absorb carbon dioxide in pre- and post-combustion method or to purify air in oxy-fuel combustion method. CLC, the energy penalty of adding gas separation unit is removed, as it inherently prevents the mixing of carbon dioxide with diluting gas species like the nitrogen gas.
Thank you, James, for the detailed explanation on the CLC. But we have something better, which is called chemical looping with oxygen uncoupling, CLOU. Let's focus on the fuel reactor. The solid coal produces chars and release volatiles under the high temperature. The volatiles could directly react with the oxygen carrier, which is the OC, but the char needs to undergo gasification to be able to react with OC. If we choose the OC, they have the ability to release the oxygen. The solid fuel could directly combust with it without undergoing the slow gasification process. In this sense, the gaseous fuel reacts not only with the molecular lattice oxygen on the oxygen carrier, it also reacts with the direct oxygen released by the oxygen. This is a combination of heterogeneous and homogeneous combustion reaction. Unlike under the CLC condition, The only lattice oxygen is available for the oxidation reaction. That is only gaseous fuel combusted using the heterogeneous solid gas reaction. In general, the OC for CrOU needs to have special characteristic and needs to react reversibly with the gas phase oxygen under the high temperature. This places special thermodynamic and kinetic demands on the OC, which are not needed in CLC. The OC for CrOU must have the ability to react with both oxygen from the air to fuel reactor and release this oxygen to decomposition in the fuel reactor. Thus, the CrOU utilizes the fact that some metal oxide have a suitable partial equilibrium partial pressure of the gas phase oxygen at a high temperature for combustion. Some metal oxides based on copper, manganese, and cobalt have this distinctive property and we'll discuss soon. The oxidized form of copper is copper 2 oxide and it will be reduced to copper 1 oxide. Copper-based materials show both high reactivity and oxygen transfer capacity, and their relatively low cost and low toxicity make them an attractive choice as OC. Also, sulfurous impurity in the fuel do not significantly affect the performance of copper-based OC. Look at this graph. It is undeniably that the copper oxide is the best oxygen carrier candidate, where it shows the highest oxygen carrying capacity among all. Every single gram of copper oxide could cope with 0.1 gram of oxygen from air to fuel reactor. In this same graph, there are also cobalt and manganese-based OC, but their performance are not as good as copper-based OC. Even though the attention is on the copper-based OC, it is unlikely to get a pure copper, as in the copper ore. If it does, it requires expensive cost to manufacture it. So, researcher has found an alternative way to mix the copper oxide with other elements, resulted the CuAl3O4 and CuMn3O4, to reduce the expensive cost of manufacture a pure copper oxide. However, these two candidates are not able to have such superior oxygen carrying capacity as pure copper oxide. To wrap up, copper 2 oxide is undoubtedly the best candidate oxygen carrier in CrOU.
Thank you, Yongxin, for the explanation on oxygen carrier. Moving on with the comparison of CrOU with other methods of coal power generation. Let us look at this graph. This is the net electrical efficiency obtained from Aspen Plus simulation. Net electrical efficiency is calculated by dividing the net electrical output with the lower heating value of coal. From this graph, we can clearly see that the conventional methods of carbon capture, which are oxy-fuel combustion and pre-combustion, have the lowest value of net electrical efficiency, followed by coal direct CLC, which is discussed by James just now, and also integrated gasification combined cycle CLC, which is a hybrid technology. However, from here, we can see that CrOU exhibits a significantly higher net electrical efficiency, as high as 48.07% when compared to other existing methods. Next is the economic considerations for the scaling up of a CrOU plant. According to our rough estimation and calculation, for a 100 megawatt CrOU plant, which can cater to 300 homes, the net profit after tax is 78 million euro per year. However, the profit is solely based on the electricity tariff in Europe, along with its operating costs and data. For the construction of plants, we estimate the return of investment, ROI, which is the performance measure to evaluate the potential return and the efficiency of an investment. The ROI of the CrOU plants is 35.8%. The payback period, which is the amount of time needed to recover the cost of investment, is approximately 3 years. This economic data results in high ROI and low payback period. But remember, this is just a small-scale plant with the capacity of 300 homes, and the calculation ignores the time value of money. How about the carbon emission of this CrOU technology? Let us take a look at the specific carbon dioxide emission. It is a measure of carbon dioxide released into the atmosphere per unit energy produced. Data from Tenaga Nasional Berhad, which is Malaysia's largest energy provider, shows that the carbon dioxide emitted per unit energy produced from this plant is 540 kg per megawatt hour, whereas the oxy-fuel combustion from the simulation has the measure of 70.69 kg per megawatt hour. However, this is nothing when compared to coal-direct CLOU. With CLOU, we can go as low as 1.05 kg per megawatt hour, which is a few hundred times lower when compared to TMB. Although this does not reflect the real scenario as this is just a simulation, this shows the potential and sets the upper bound of what CLOU is capable of doing. That's all for our presentation. Thank you.
All right, thank you, Team SG20 A026 for your presentation. And for the Q&A session, we have Dr. Stephen to ask questions. Please welcome.
Okay, so good afternoon, students. Again, a very good presentation, especially on the concept of CLOU, chemical loop oxidations. So I'm just wondering on your choice of the catalyst. So of course, you guys are proposing the usage of copper oxide as the best catalyst, right?
Right.
So, but of course, copper oxide, although it's quite efficient, but it has drawbacks also that is easily deactivated. So have you guys considered its lifetime cycles and also how you deal with the deactivation of the catalyst for this system? Thank you.
Yes, thanks for your questions. So the copper oxide is the oxygen carrier. Basically, they have some many consideration to pick copper oxide. First, we need to consider that first challenge is the agglomeration and the lifetime cycle. And for research, for the literature, they have some shown that zirconium oxide as a support to attach with the metal oxide, the copper oxide will improve the mechanical properties of the copper oxide, and that also will prevent agglomeration and extend the lifetime. For our and James, could you add on about oxygen carrier?
Okay. So basically, if it was supported by zirconium oxide, it will have a lifetime of 92 days, which means we have to replace it every 92 days. But there is some researches are going on for alumina-supported copper oxide, which could bring up the lifetime to 5,000 hours, which means 208 days.
Yeah, despite the alumina will extend the lifetime, the ability to release the oxygen is not as high as the zirconium base of the support material.
Yeah, but of course, if you're using zirconium-based material, then you'll be add on to the cost, right, to your catalyst, then it will be more costly. Do you think it's worth it?
Because we remove the separation unit, because typically you need a the coal to undergo gasification to produce syngas, so you can go to subsequent combustion. But in this scheme, we could combine the gas separation unit, the combustion unit, and the gasification unit into a unit operation, and this could reduce the exergonic destruction of having multiple unit operations.
Okay, thank you. Thanks. That's all for my part.
All right, thank you, Dr. Stephen, for your question. And we can have maybe the last question from Madam Nurida, the last question for this pitching session. Nurida, would you like to ask a question? All right.
Okay, thank you, Tim, for the presentations. I can see that you actually did the calculations on the costs of your new system, the calculations on the 300 megawatts, I think 300 homes base calculations. So what is the comparison between the systems that you have to the current combustion system that is already in the market?
Okay, so for the current market, they use pre-combustion and oxy-fuel combustion. We emphasize already on the net electrical efficiency, which have what? Can you go back to the?
You have made comparison to the efficiency, I can see, but how about the operating costs of the current system and compare it to your system?
We have not done that analysis work to compute the conventional method operating cost yet.
Okay.
That's
So
all
you only did on the efficiency, but not really on the operating cost yet.
Yes, but in our opinion, I think that with the higher energy efficiency is the reduction in the energy demand from the system without affecting the normal activity. So it shows that we optimize the system so that it has higher energy efficiency and it will reduce the economical cost of operation.
Yep. I can see that the way forward, you guys are going to do the scale up. You are going to do the techno-economics evaluation, and it is always good to actually compare to the current one, so that your technology is not just better in the sense of efficiency, but also needs to look at how well the operations cost or lower the operation cost can be by using your technology. Okay.
Yeah, I understand.
Okay. Thank you for your feedback.
Right.
Thank you very much.
Thank you.
All right, thank you, Madam Nurida, for your question, and thank you, Team SG20A026, for your presentation. All right, that ends our pitching session from our 15 finalists. Hopefully, their ideas and work on climate action could serve as a motivation to all of us. In order to combat climate change and work towards preserving our Mother Earth for future generations to come. Apart from the pitching competition, SEA-GIC 2020 committee has organized a poster competition regarding COVID-19. A total of 41 participations from Southeast Asia region have submitted their posters. Please enjoy the completion of COVID-19 posters prepared by the organizers. Welcome back to Southeast Asia Global Innovation Challenge 2020. Next, we will have our second renowned keynote speaker, Professor Dr. John Holbury from Queen's University, Belfast, United Kingdom, to share his vast knowledge and approach on green chemistry entitled Recycling of Water PET Using an Ionic Liquid Derived from 1,3-dimethyl-imidazolium 2-carboxylate organocatalyst. Please welcome.
Thank you. I'm not sure how to respond to that really nice welcome.
You can try to request control.
Okay, I will have a go at that.
All right.
I've got to find the right button.
Yep. Is it?
No, I don't have a request control.
I think that's okay. We can control the slide for you and just give us the cue. All right?
Okay, that's perfect.
All right. Okay.
Okay, that's great. So thank you everyone for the invitation to speak at your meeting, and it's actually nice to see familiar faces in the audience as well. I'm looking at the attendance list. What I'm going to hope to do is tell you a little bit about work and a bit about a pathway that we've been going through for a number of years in our research, or my research, both in Alabama at certain points and especially now at Quayle in Queen's University in Belfast. And I really want to try and motivate everyone a little bit by showing how looking at fundamental chemistry can lead to unexpected results and unexpected areas of opportunities for applications and advancements, especially in the context of this meeting, in addressing or potentially addressing climate change. And I want to hope at the end to really discuss and show you where aspects of the chemistry can lead to impacts across a broad range of areas. So not necessarily looking specifically at the science we're talking about here, but how it impacts across that broad range of changing chemistry, but also impacting and lowering our carbon footprint through how that can change engineering as well. So I think it's really important for us as chemists especially to be quite holistic about this. So thank you. The first of these slides is where we start. And actually, I'm not that old. We started off one aspect of work being wanting to look at using the technology we look at ionic liquids to change how we treat and use biomass, in particular try to have ways of looking at cellulose processing to try and get to rayon and cellophane and cellulosic wrappers. And we were inspired by work from the 1930s in Switzerland using pyridinium salts as alternatives to the xanthate process for dissolving cellulose. So you notice this was using a pyridinium salt which melted at about 150 degrees. If we can move on, next slide. What we developed and what we looked at was seeing if we can use more conventional, at least by the 2000s, more conventional ionic liquids, particularly imidazolium salts, to do the same work. And of course, we have a very well-cited and well-recognized piece of work in this area, identifying that imidazolium halide ionic liquids are very good solvents to cellulose. And this led to a lot of effort to see whether this could be commercialized and used in an effective way. If you look at the next slide, you can see that the idea is very simple, and we like simple ideas. We could take crystalline or microcrystalline cellulose, dissolve it very rapidly with ionic liquids, and then regenerate this to form fibers or beads or films through normal technological processing by recoagulation, reprecipitation in water, and then recover and recycle the ionic liquid. And this is the model that we had, and we developed demonstrations of how to do this. Let's go next. Perfect. Next slide. As researchers, as chemists in academic labs, we're not always very well prepared to fully develop and exploit technologies. So this was research that was moved and sublicensed to BASF as one of the biggest chemical companies in the world to see if they could do more with it. And they, of course, put a lot of people onto this and screened a whole load of ionic liquids. And what they identified from a massive amount of work was that ethyl methylimidazolium acetate was identified as a good solvent for cellulose dissolution. So I've got it highlighted there. And this led in the next slide to them trying to develop technologies based on that. But I guess as chemists, we should have realized that there were some unexpected consequences from this. And I want to highlight this because this leads us into what we're doing now. One of the unexpected consequences is that you can use imidazolium salts in the presence of base. And the acetate anion that was used is, of course, quite basic to generate N-heterocyclic carbenes, which can be used for a whole host of different chemistry. And why I say this is an unexpected consequence that we should have known was that Anthony Arduengo was on the previous slide. I guess this is changing on its own. Was actually the other end of the corridor from us at the University of Alabama while we were doing the work. And he had worked at DuPont in developing the classic work on these carbenes. So I guess we should have known by realizing what our colleagues were doing that this might have happened. If you move on to the next slide, this is recognized and is utilized now. And here's a beautiful piece of work from Professor Tom Welton at the University College London, in the Imperial College London, he'll kill me for that, utilizing the presence of carbenes in ionic liquids during the dissolution of cellulose to recognize how this can induce chemical reactions. So really what I say is there's a lot of unexpected consequences come out of needing to know what's happening in the chemistry you're doing. And in this case, it's the generation of carbenes. Let's look at how these carbenes do something with PET here. So what we're interested in now is looking at polyethyl terephthalate waste. So waste plastic bottles, waste clothing. And we want to look at the recycling of it to try and improve on or to complement the physical recycling that can be done by just simply melting and reprocessing these materials. So next slide. So this is a schematic which I use in teaching to our chemical engineers about the concept of integrating chemical recycling, which we can see here, I guess. Do I have a, no, I don't have a pointer. Chemical recycling into mechanical recycling to try and recover both energy and resources from, in this case, waste plastics as part of a circular economy approach, which of course is what we want to do. Let's look at what we're trying to do in the next slide. So what I want to show you today is work here that we've been doing on, on recycling of polyester by glycolysis using an ionic liquid derived catalyst, and I'm going to show you how this can actually lead to some advances. There's our beautiful picture. That was the graphical abstract for the paper. Excuse me a moment, I'm getting a call which I have to answer. Hello? Yes. There is. No. Sorry, it's not Knockeden Park. It's 2 Glenna Crescent carried up. We used to live there, yes. Okay, can I give you my mic?
Hello, sorry.
I'm terribly sorry. I'm back about that. Unexpected things clashing with this. So we want to look at this glycolysis with PET. Can I get the next slide? So the idea is that this is one of the primary feedstocks for the petrochemical industry, and what we're trying to address really is how we can get away from using petrochemical resources to reduce our chemical footprint, our demand on things, and actually potentially more than anything else try to maximize the use of petrochemical resources for useful things other than necessarily as fuels, which will lead to our carbon emissions and things like that. And the recognition that we teach is that most of our chemicals come from these primary chemical resources. And to that, really, I want to highlight here ethane, C2, and xylene, C8 fragments, which do lead directly to polyester manufacturing at a massive scale. I've got some noted figures, which are actually a bit out of date now, but US chemical production was in the order of 300 million tons a year, of which, of that, something like 120 million tons a year is to generate chemicals and polymers, and polyester is a major contribution to that. Can we look at the next slide? And you can see very easily how it's done, and this is, for the engineering side of people in the audience. The process of doing terephthalic acid is to take terephthalic acid, and ethylene glycol, to heat them and dehydrate them over normally an antimony catalyst, removing the water. It's a very simple integrated process. The next slide, please. And as you can see, it is a beautiful and very much a vertical process that works well within the within the petrochemical industry. You can go directly through from crude oil through production of xylenes, generation of polyethylene glycol from ethylene to make the polyesters. What we're trying to do and what we're going to look at in the research, next slide please, is how we can break out of that petrochemical approach and get something useful, I hope. So, and this is my justification, this is my pitch if you like, though we're kind of halfway through. Over 50, probably close to 70 million tons of polyester produced every year at the moment, used for everything. Most visible aspect probably is plastic bottles, drinks bottles, and the value of the resin for this is high, which justifies why it is worth recycling it rather than just burning it as a energy resource, as a waste product. But I would note, and let's get to the next slide, that what's really important is that though we can regenerate this physically by melting and reprocessing, that does lead to impurities and ultimately to weakening. And the reality is that most recycling of polyester, as you note here on this slide, this is actually done about 10 years ago, it's recycled and generates what's called fiber. This makes things like carpet tiles, thermal fleeces, things like that. So it's not being kept within its primary use for packaging, for bottles, for high performance uses of the polyester itself. So what we're trying to introduce with our chemistry here is to take the polymer and break it from this. This is my representation of polymer using Lego. The polymer made of component units, and break them down in chemical terms into its component units, which is, next slide, like this, so that we can take our chemical units perfect and regenerate them and build up the polymer again. Because once we've got, from a chemistry perspective, from those chemical subunits, they're chemically identical to those that we generated from the petrochemical process in the first place. So our role as chemists in recycling is to try and get chemicals which are identical to the things that we started with. Okay, next slide as well. This is the strategy. Let's go to the next one. And the next one. That's it. What we're going to look at is glycolysis. The approach of taking polyester, this polymeric ester of terephthalic acid, and we're going to add to it ethylene glycol. And in doing so, if we can crack the ester, a straight, simple chemical reaction, we can make what's called BHET, which is actually the first intermediate in the polymerization process. So we're breaking this down into components and go straight back into the polymer food chain. If you look at the chemistry of this, there's a wide range of catalysts that have been studied, and I've got a bucket list there of things. Most interesting things are metal acetates, really, and I'll highlight some use of those in a second. But also I would note here that in current research, ionic liquids have been looked at, and carbon catalysts. Excuse me, I really do have to pause for a minute. Sorry. So we're talking about trying to crack the polyester this way, and we can use a wide range of catalysts. Next slide, please. And as I say, the most common thing is zinc acetate. Please bear in mind the results that we got on there. Without the catalyst, if we just heat the polymer at 190 degrees, eventually, after about 6 to 7 hours, you do get cracking. We do get deesterification and production of monomer. In the presence of zinc acetate, after about 30 to 40 minutes, we can get about 60% yield conversion to the BHET. And this, if you like, is probably industry standard. This is as good as you normally get, and it works perfectly well. 1% zinc acetate as a catalyst. Let's move to the next slide, because we're not interested in terms of ionic liquid research in zinc acetate. we're really interested in trying to see what we can do with our materials. And of course, we're not the only people who've been looking at this. If you send the students to look in the literature, they find that there's lots of research going on looking at potential to use things like ionic liquids as catalysts to induce esterification, trans-esterification reactions. And I've just cherry-picked some very good work there, especially from Suzhan Zhang's group in Beijing, on looking at the uses of a range of ionic liquids, particularly containing metals, which are analogous, if you like, to the zinc acetate as catalysts for this. So very good, they do work, but we are asking, can we do better? So next slide. Let me just jump through this. And what we noted, and I want to lead you through to where we can get with this quite quickly. What we noted is actually using one of our old friends, imidazolium acetate ionic liquid, one of the materials that we were looking at and BSF were looking at for cellulose production. This could be used, and it was reported that this gave, I've highlighted in the box there, relatively good conversion. You know, this group could actually get up to about 50% yield and about 75% conversion of polyester to product using the ionic liquid as a catalyst. Now, this might be ringing bells from the start of what I said, 15 minutes ago, that you could generate carbines, as we saw, or as Tom Wells and other people saw with imidazolium acetates, with looking at cellulose, with this ionic liquid. And indeed, it was speculated that formation of an heterocyclic carbene from this ionic liquid could be driving the mechanism for this catalysis to get this material. But it's interesting because it doesn't contain a metal. So there's an opportunity there to change the catalytic process. Let's look at the next slide, move on. I'm going to note, because we're trying to do a bit of a literature survey as we go through this, that using N-heterocyclic carbines as catalysts for esterification chemistry, both making esters and doing trans-esterification, was already known and had been identified for a range of reactions, including making things like polylactide from PLA, so quite green renewable polymer sources can be made with using these carbene catalysts to drive the reaction. And also, I'm going to note in highlighting this box, it's really good from Lefebvre's work, that they looked to identify using trans-esterifications using both imidazolium carbonate catalysts and also this material there, number 3, a carboxylate, as a precursor to carbenes. Let's look at the next slide. This sparked our interest because we'd looked a long time ago about making the zwitterion, actually for completely different reasons. But as we know, it is being used as a source of CO2 protector carbene to deliver carbenes as reactive species. So we tried to look at this and said, okay, can we use this material that we've got in the lab that we've looked at quite a lot as a precursor to do the same chemistry that's been seen with the ionic liquids as interesting catalysts? So let's go a bit further forward. Let's next slide. And I'm going to skip a few things here. So again, the next slide. And there's the time. This is the key point, is we have on the left here an imidazolium cation, which has got the potential in the presence of base to make carbene. And the carbene has been implicated as a very good basic catalyst for a lot of reactions, including the esterification. On the right, we've got the zwitterionic carboxylate salt, this carbene that's protected by CO2. And if you decarboxylate that, you can also form the carbene. So the interrelation between these two species, both of which could form and react to generate a reactive organocatalyst. Next slide. I want to show a few results, but nothing really too much. This is what we did. We tried to take both on the left and on the right, the imidazolium salt and the carboxylate zwitterion, and compare them both as catalysts for this reaction, which is taking polyester PET, and it's actually chopped up Coca-Cola bottles. There are other bottles available, and doing this reaction. And we can do that reaction, and we can generate at the bottom. It's not come out very well, but a beautiful white crystalline BHET material, which can then be recycled and reused to make more polyester. So it works well. Let's look at the next slide. And here's the data we get. Well, what's really was interesting and amazing to us was that using the carboxylate, the zwitterion, which is the blue line up here, we can see at any reaction we try, at any temperature or at any rate of time, the conversion was a lot faster and a lot more effective than it was with the acetate salt. So that's our take-home message. Okay, next slide. I think that's what. This zwitterion is a much better organocatalyst than the imidazolium salt. We presume, and it's going to take more work to look at mechanisms, that both of these can generate the N-heterocyclic carbene as our reactive intermediate, and that's the actual catalytic species. So the presumption is that the carboxylate can generate the carbene more effectively, more rapidly, and therefore lead to quite remarkable levels of conversion of PET to BHET as intermediate. Okay, next slide. Next slide. I've just talked about this. Is it much better? Yes, it is. Should we use this for certainty? Let's just stop there. Next slide. So I'm going to say we've got this opportunity. We've got a catalyst that works. Is it worth using properly? Well, this is the interesting point. I just want to leave you to think about this. If you go back to 2010, Journal of Chemical Education, so looking at the educational literature, there was a really nice article by Neil Camber on generating an N-heterocyclic carbene under anhydrous conditions in THF, so classic carbene chemistry, and demonstrating this in an undergraduate organic chemistry lab to do PET cracking to BHET. This is very rapid and works at reflux in anhydrous THF. So if you all think about the boiling point of THF, that's about 40, 50 degrees, right? Compared to the 180 degrees that we use commercially to do this. There's our opportunity. Can we learn from the chemistry we're doing? Can people take that chemistry and reduce the operating temperature for this cracking process from 180 degrees, which is commercial at the moment, to something approaching the temperatures that can be done in a lab, but under anhydrous conditions, which are artificial and not realistic. There's a massive thermal window available to improve on the energy savings that have been gained in the chemical engineering side of the process by modifying and identifying the right catalyst for this system. And that's our window of opportunity to try to look at. So what I'm hoping to show, what I hope to show you in this very quick flyby of this, is that there's an opportunity to recycle materials in alternative ways. We've got to learn from the chemistry we're doing and look at it sometimes in different ways, and also perhaps listen to what our colleagues down the corridor are doing as well. If we'd done that 20 years ago, we might have learned a lot more about what we were doing with the cellulose dissolution. But also, I think from a pure chemistry perspective, there's great opportunities for us as chemists to influence on energy savings and controlling, especially carbon emissions, by influencing and improving on the engineering aspects of processes rather than just on changing the activity in the chemistry. And that's a really important area of thing. So that's it. Can I just leave you the last slide? I just want to acknowledge the people who actually did the work. So it's not me. It was primarily an MPhil student, Lei Wang, who I really want to highlight there, who drove a lot of this work through a single year master's program. So she was very good at this, and I really want to congratulate her on that. And thank you all for listening. And sorry for the interruptions I've been having while we've been going through this. And if anyone has any questions, I'm quite happy to answer them.
All right. Participants, if you have any question, you may direct your question in the chat box. Yes. Let's wait for some time. Question.
So, Cecilia's asking, what other anions can be used? Well, in terms of the work that other people have looked at, they've tried just about every anion present in the ionic liquid side of things. Certainly, if you use a basic anion like hydroxide, carbonate, acetate, you would infer and induce that it's making an N-heterocyclic carbene, and then we expect the carbene catalytic route to take place. But also, especially Zhang has looked at chlorometallate systems or general organic liquids with metal salts dissolved in there. And then you have to sort of think that there's potential for mechanistically to this act as both a combination of, it's kind of a push-pull mechanism. You need a base, and any anion is going to be slightly basic, but you also probably need a Lewis, some mechanisms also need a bit of a Lewis acid to coordinate on the carbonyl group of the acid of the ester to drive the cracking of the ester, just as you would in any esterification and de-esterification reaction. I have to say, trying to understand the results that are in the literature is very difficult, because a lot of papers will say, okay, we tried something and we get a good result. And it seems to be black-white. You either get a good result and you publish it, or you get a poor result and you ignore it or hide it away. And that's unfortunate, because it doesn't really give us, when we're trying to collate the information, understand what's going on, really how to drive things forward. I think what we're trying to identify here is that the carbines as super bases are definitely very good materials for inducing this sort of catalysis, and we've got a mechanism here to deliver the NHC in a way that makes it reactive. The challenge is to protect that now in its environment, so it's not killed by the presence of water and other things in there. But I think there's great opportunities from that. Okay, there's another question here. Intriguing session. While we know anti-liquids, there's lots of hype. Some of them are costly. How would we, as chemists, enter green recycling rather than burn plastic waste? I think it's really important. Yeah, it's kind of the lowest denominator, isn't it? That we can always burn plastic waste to generate energy. That is the lowest common denominator. I think what we have to realize is that our whole society has been technologically advanced by our knowledge of making composites, and composite materials are really great. Don't get me wrong, I wouldn't like to fly on an airplane which didn't have a composite wings. But at a simpler level, we see in plastics, composites, mixtures which have really great performance, but it really screws up and makes the recycling of them difficult, because it puts so much emphasis both on, as we've seen in some of the presentations, separation at the recycling site, being able to identify different polymers. But then if you've got something like clothing, which is a blend of polyester and cotton, recycling of that is almost impossible, because you're trying to split out fibers of different polymers from each other. And I think we have to, in some ways, think about educating society to step back a little bit from some of these technological solutions to things that actually overall are better for society, but may not in the short term be quite so benefit. One example that comes from this, I just say, and it is part of this green education, is that we've seen two things. One, Sprite have switched from green plastic bottles to clear plastic bottles. Why? Because it actually makes them easy to recycle, because they don't include the dyes in there, which when they go into a clear plastic recycling blend, contaminate it. That's really good. Has it had any impact on the flavor and the taste of the drink? No. But it's really important that we can, that sort of awareness about the need for recycling has made that change. And it hasn't had an impact on life other than it improves the recycling. Making sure that the tops on plastic bottles are made of the same polymers as the bottle, rather than something else, means that we're not inducing blends into our mixtures which are difficult to get out of. And these are the things that I think are really important to do, and are very simple if we educate at a low level, from school children upwards, that these things can make the difference. Then we can try and solve the problems rather than having to making it a sorting issue. And I think we need to be advocates of that, not just of the high technological solutions, but also of the simple things that can be done.
All right, understood. I think that's all from the question from the chat box. And thank you so much, Professor Dr. John Holbury, for the educative sharing session. Thank you so much.
Thank you very much. And I think it's been your meetings worked very well. I've joined the latter half of it after I woke up. It's a pity I can't be in Malaysia to participate with everyone in person, but that's the way we are at the moment. But I'm really glad to see it's working virtually.
Yes, true. The pandemic, very true. Virtually, yes. All right. Thank you, Prof, for your educative sharing session. All right. So, before we move on to the main highlight of our event today, kindly please scan the QR code provided on the screen. Your kind cooperation and any feedbacks regarding the SEA-GIC 2020 would be much appreciated, and we would strive better to make our event more successful. All right, participants, can you call your friends to join our meeting again, because we are going to do the closing session very much soon after you all has finished fill up the feedback query. Then we'll proceed to the closing ceremony very much soon. Mr. Yeah, it is supposed to be editable so that you can fill up the questions regarding our questions. I wouldn't say question, I would say feedbacks about our event, and perhaps we can improve our event for future references. Yeah, please take your time filling up the feedback query. Yes, and please call your friends to join our closing ceremony, which is going to happen very much soon. About the feedback query, please wait for a while. My team is working upon it. Give us one moment to fix this. Yeah. Participants, you may fill in the feedback about SEA-GIC. You can refer to the link that is given in the chat box. Yeah. All right. All right, welcome back to Southeast Asia Global Innovation Challenge 2020. And now, the moment that you all have been waiting for, the announcement of winners for poster and pitching competition of SEA-GIC 2020. Let us welcome our Chair of SEA-GIC 2020, Dr. Siti Nur Azila Zaini, to announce the winners. Please welcome.
Okay, for the poster competition, the third place goes to Alif Solihin from Indonesia. Congratulations. Second place goes to Ayu Moralisa from Indonesia. And the winner for poster competition goes to Aulia Rahman, also from Indonesia. Congratulations to all the poster competition winners. For pitching competition, competition prize, fifth place to the project titled Generation Carbon Capture and Storage, Chemical Looping with Oxygen Uncoupling, A026, University Science Malaysia. Fourth place goes to project Artificial Vertical Algae Forest Carbon Capture and Marine Ecosystem Restoration, A052, Universitas Aisyah Yogyakarta. Third place goes to the project title into electrical energy using an electrochemical method, E002, University Science Malaysia. Second place goes to the project title CO2 utilization in E033, Swinburne University of Technology Sarawak campus. And the winner goes to the reduction of CO2 using algolite, Universiti Teknologi Malaysia. Congratulations.
Congratulations to the winners, and it is with a great pleasure that I now shall invite the first prize winner to give a congratulatory speech. Please welcome the representative of the group SG20A042 for your speech. Please welcome. Can we have a representative from group SG20A042 to give a congratulatory speech?
Good evening to organizers, fellow judges, and all the participants. First of all, we'd like to thank the organizer for organizing this awesome competition. And actually, we don't have nothing much to say, just that we are very impressed by all the inventions proposed by all the participants. And we really do hope that we can see all these inventions to become, to realize in the future. So once again, thank you all and wish you all the best. Thank you.
All right, huge congratulations to all the winners. And as per se by Dr. Muhammad Firdaus earlier today, the chair of ACS Malaysia chapter, he said that whoever have win, you all have played your role in promoting chemistry in battling the climate change. We are proud to see the young scientists and are contributing to society through their research for the betterment of the society and advancement of the Southeast Asia as a whole. SEA-GIC has been serving as a platform for the undergraduates to showcase their impactful projects since 2016. ACS-UTP is truly honored to host SEA-GIC 2020. This is the first time this event is conducted virtually. And in 2021, ACS Malaysia has nominated another ACS student chapter to host SEA-GIC 2021. Let's find out the next host for Southeast Asia Global Innovation Challenge. Video remarked as a symbolic to the handover of the next SEA-GIC host. We would like to invite representative of SEA-GIC 2021 host, Dr. Izzat Faimuddin Muhammad Sofian. Dr. Izzat is the co-advisor of American Chemical Society of International Islamic University Kuantan Student Chapter. Please welcome.
Assalamualaikum, can you hear me? Can you hear me?
Can you speak louder a bit?
Okay, just give me a second. I think it's fine. A better. Yeah, I think it's quite normal for virtual right now. Like sometimes you need to find a better place to have a better coverage.
Totally understand.
Okay, can you hear me clearly?
Excuse me?
Can you hear me clearly?
Yes, yes.
Okay. So yeah, hello everyone. Assalamualaikum and good afternoon. Good evening. It's already like 4:40. So as introduced just by the MC right now. Just now, my name is Izzat Sofian. I'm co-advisor of the American Chapter Society of International Islamic in Malaysia. So I think for the next year, 2021, the Southeast Asia Global Innovation Challenge SEA-GIC 2021 will be hosted by us. Hopefully we could have the physical by next year. I'm not sure what will happen by next year, but if not, like, it will be kind of like similar like this year, the virtual one. And we are looking forward for next 2021 SEA-GIC 2021. I welcome everyone to join, and hopefully by next year we'll see more participants from other countries to join the event. And I'm really proud with this year event organized by UTP. ACS-UTP, you guys really done a great job, and it's really a benchmark for us to do at least as much as possible like you. So I think that's pretty much from me. Like, so please do tell your friends, your lecturers, your colleagues, your members to join SEA-GIC 2021 next year, organized by International Islamic University Malaysia, IUM, ACS.
Thank you, Dr. Izzat Faimuddin, for your speech. We are looking forward to SEA-GIC 2021. Before we end this event, I would like to invite all participants to kindly turn on your camera for us to commemorate this virtual event.
There's something that's not answered, being answered. They want to research active, they are able to do it. I'm not really sure whether you can understand it. For example, if you are doing if you do coding, it's what I was talking.
This marks the end of SEA-GIC 2020. We would like to express our deepest gratitude to the excellent speakers, honorable judges, participants, and audiences for making this virtual event a successful one. Thank you, and see you in the next SEA-GIC. Bye. Participants, do you mind to again turn on your camera so that we can take one more appropriate photo? All right. And we have participants to turn on the camera. But hi participants, do you mind to turn on your camera so that we can commemorate this virtual event? It's the only perhaps virtual SEA-GIC, right? So let's take a picture with all the audience's judges as well. Please turn on your camera so that we can take a picture together. Yes. All right, 1, 2, 3, smile. All right, another one. All right, 1, 2, 3, smile. All right. Okay, now we freestyle. All right, 1, 2, 3, peace. Okay, done. Thank you. Bye. Have a nice day. Right. Last announcement to all winners, please. All right, to all winners, please be noted that our committee will be in contact with you regarding the prize through email. So yeah.